Sir, shall we start?
Hello, good morning. Yeah, it depends upon you
Yeah.
if your
Yes, sir. So the
participants have joined.
participants will keep joining, sir. We'll start on time, sir.
कोई बात नहीं कर लीजिए.
Yes. Okay, sir. A very warm good morning to all our speakers, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, faculty members, students, and to all the participants. I welcome you all on behalf of Suresh Gyan Vihar University on the 17th day of 21-day winter school in Geospatial Science and Technology. We are very delighted and eagerly looking forward to have you all involved in this esoteric program. With this, I would like to take a brief moment to introduce our guest speaker, Professor Devdutt Sharma. Professor Devdutt Sharma is the Director, UGC HRDC, Himachal Pradesh University of Shimla. And he holds a long research and teaching experience with a span of over 29 years. He has supervised many PhD and MPhil scholars. He has published many books, research papers in national and international reputed journals. He has completed projects on disaster risk, response, and management in Himachal Pradesh. He is lifelong member of several academic bodies, including Indian Science Congress, Asian Environmental Council, Indian National Association of Geographers India, Indian Institute of Geographers, Indian Meteorological Society, Punjab Geographers, and so on and so forth. Now, on this note, I would invite Professor Devdutt Sharma for taking today's program forward. Sir, you're most welcome.
Yeah, good morning. Am I audible?
Yes, sir.
Thank you very much. And at the outset, I would like to convey my heartfelt thanks to my student, Dr. Shruti, for having invited me and given opportunity me to meet many youngsters and many new promising research scholars. Uh, Friends, few days back when Dr. Shruti called me to give a talk, and what she has been suggesting, in fact, is not really my core competencies. But yet, it's very difficult to say no to some of the dear students, and therefore I'm before you for this particular lecture today. As I've been told that the Suresh Gyan Bihar University, it has been conducting so many such workshops, so many such faculty development programs in which various number of scholars are attending, and at the same time you'll be finding many learned speakers from the other side. Good morning, Shruti.
Good morning, sir.
So friends, let me say with this thing that I'm not an expert for this, but I say one thing that I do not say no normally, and that is because that I keep on learning. I believe in learning. And friends, before going to the topic, I would like to say that everyone should be a lifelong learner, especially who are in the academics. They have to keep this close to their heart, because the day we think that I know everything and I don't require to add anything to my existing knowledge, I think that's the doomsday for any of the teacher. So especially with this geospatial technology, when many of my contemporary or the senior, they say that this is something which is just a methodology, which is not something akin to us. But still, I feel that some of my scholars, they have been working on certain issues, which I admit that I do not know much, but still I keep on learning something from them and something from others. And therefore, this topic, especially the geospatial technology, application of geospatial technology for the rural development or for urban development, I think this is a cheeky knowledge that I'll be sharing with you. So let me go to my presentation. Shruti, how is the weather condition over there? आप कहाँ पे हो? You are at Jaipur or in Himachal?
Sir, Jaipur.
In Shimla, it's very, very cold.
Sir,
और
even
अभी
it's
तो अभी तो
cold here
टैप भी
also because a lot of winds they are continuously coming
अभी
from
अभी
Shimla
तो
to
टैप
Rajasthan.
टैप भी बिल्कुल बंद है. टैप इज फ्रोजन. मेरी स्क्रीन आपको नजर आ रही है?
Yes, sir. Yes, sir.
Okay, so friends, this is the thing that I'll be sharing with you. And let me tell you what I've been saying, that I'm not certainly an expert in it. And वो कहते हैं ना, वो लोग कभी कभी हमने अपने दिल को कुछ यूं भी बहलाया है, जो खुद ना समझ सके वो औरों को समझाया है. तो आई थिंक ये उसी का एक just I have joined from other one also. So because in Google Meet the problem is one that you know that when you put the things on uh, slideshow, you don't see yourself and the participants who are there. So that's this thing. And friends, I'll be talking some few things in the beginning as general, certain general things about this thing, and then I'll be taking you to one of the case study on which one of my scholar is also working currently for his research degree. So, friends, when we are talking about the geospatial technology for rural development, so we should understand that the rural development, of course, is or has become a buzzword because always there has been certain issues that the development is pocketed to certain areas only, and having the holistic development and especially taking it to the rural area, it become further questioning, and especially during the election times, you can see that this is always one of the issue. And you can say that this rural development is a complex blend of offering opportunities and avenues which fulfills rural aspirations for the sustainable development and growth. That's the main thing, and why we are talking about using of geospatial technology. I think we should always remember that however, there have been many efforts of the rural development or any other development in past, but once the development activities are done in isolation with the requirement of that area or requirement of any region without knowing its physical characteristics or other things, I think it results not in a good return and sometime in havoc. We should also remember one thing that especially in some of the examples, if I give you, there are certain very good examples, and one word or the carrying capacity which started or which was originated probably in engineering, that has traveled to economics or geography, because the carrying capacity, why I'm using this word over here, because in many areas some of the efforts have been done without understanding the capability or the capacity of that area, and anything which goes beyond its carrying capacity, that has been something the results we have seen, which has resulted in certain disasters, which has resulted in desertification, which has resulted in deforestation, or many such things. So that is therefore that if we use the geospatial technology, then certainly we can be aware of any area about its physical and other characteristics, or especially the capability of that region, and we can suggest, or we can have some idea that what sorts of requirement and what sorts of planning is required in that region. And we can say that the necessary infrastructure which is always required for any sort of development, and so is the case of rural development, because whatever the activities and whatever things that we do thereafter, I think that that is referred as superstructure. For example, in Himachal Pradesh, we have many hydro projects which have come up. So what is the infrastructure for the hydro projects? Because we cannot straightway lay down some hydro projects, because the machinery is to be transported. Therefore, there is the requirement of good wide roads so that we can transport that machinery to that particular destination. So in that case, the roads, they become the infrastructure, the communication, and the facilities, other facilities, they become the infrastructure. And therefore, this is one of the important things. And we can say at the same time, there are several challenges. And therefore, we can say this, I call it GST, because the one GST that we came across only 2 years back, but this is the GST that geographers and the colleagues from the allied disciplines, they have been using for long. So this GST, which is geospatial technology, it has a larger role to play, because provision of electricity, water, education, etc., and agriculture, they are the one which are required for the rural development. And what are the challenges? Because we all know that the socioeconomic conditions, they are fast changing. We all know that the economic conditions, I think this is why we can understand, and why I'm saying over here, this economic condition, if I give you one example, when I joined the government service and in the college cadre, I had to save nearly for 1.5 years to buy a refrigerator, because my salary was some 5,500 at that point of time, and I could save only 500 a month. And the refrigerator cost was some about 9,000. And therefore, roughly, I had to save for 1.5 years. But what has happened today, even the newly appointed lecturer, assistant professor, their salary is around 50,000 plus, and they can easily buy refrigerator during the first month of their salary. So this is how the economic condition, or we can say the purchasing power of the people, that has changed. At the same time, the social conditions, they are also changing, and they have changed. Access to various type of things, that is also different. So there are many challenges in socioeconomic condition. Of course, for certain people, the socioeconomic conditions have improved, but at the same time, there is also the disparities which has happened. The one issue which is commonly faced by the people, that there is a lack of welfare programs which are required for, especially designed for the rural areas. The second thing is that transparency issue, which we can say lack of integrated urban and rural development planning. As I'm talking today, more on rural today, but you'll see that the rural and urban, they cannot be seen in isolation. What is required, that the rural and urban, they are required to be integrated, because any change in rural shall also affect the urban development. If there are if the rural areas are lagging behind in the basic facilities, in the basic infrastructure, certainly the people would be moving from that area and they will go to the cities or any urban location for better life facilities. But if all these facilities are very well developed in certain rural area, we can probably halt this immigration to the urban center and leading it to the ghettos. And we can say the no holistic and diversified view of the rural planning, which we can say that anything that is seen or that is developed in isolation. What is required holistic? Because when I'm talking about road infrastructure, then certainly if we can have some industrial development beside it, or if we can have any other, for example, even the commercial agriculture that is related to the infrastructure of roads. In many of the areas here in Himachal Pradesh, people have started floriculture. And we know that this floriculture, this is one of the perishable type of activity. And the flowers have to reach the market just next day or at least in 2 days. And therefore, when we disassociate the agriculture produce or the horticulture produce or the floriculture from that of the infrastructure, then certainly some of these issues, they remain unaddressed. So what we can say that this is something that we are required to, this holistic view. And we can say the individual considerations, rural planning, that they are also very important, I think, for this. The things like the startup, they have been very useful and people are coming with new ideas and new thought process. And we can say the less e-governance service, of course, it has improved during the past few years. Yet there are many things which still need to be improved. And there is also lack of commercial development. And there are the issue of the mindset, which is always used, which is always one, you can say the opportunity or as well as the hindrance. And at the same time, there are not many attempts which have been made. We can say the GST or the geospatial technology, which is the combination of GIS and IT, which make use of the computer hardware, software, and data to better our vision and to use it for rural planning to identify the political social patterns, market trends. And we can say the one word which is very commonly used in today's time is the geo-visualization. Of course, the vision can be with the people of the philosophy. They can have some very different type of vision. But when we say, when the people from spatial sciences are involved, we always say the geo-vision. If you see that the ex-president of one of the African country, Egypt, Mr. Nasir, he once said that they will not allow a single drop of water of river Nile to flow into the ocean. They will use whole of the water for the irrigation. Thankfully, it did not happen. Had it been, I believe that the Egypt, जो हम कहते हैं कि मिस्र को नील नदी का वरदान कहा जाता है, I think it would have been totally waterlogged, saline today. And I believe that this type of statements by any of the politicians, they are just because they lack geo-visualization. So this is something that we can take over here and discuss some of these issues. And how this geographical information system and information technology, how they can be blended together and how can they be helpful for the government agencies. We can say identifying and monitoring all rural planning which are the requirements at micro and macro levels. This is something that on this issue, the GIS as well as the IT, that become very useful tool to know the requirements, because there will be the geotagging in every such area, and this become very useful. Then strategizing using a holistic approach, because the conventional planning is still overridden in our country. In every area, people do not want to deviate. And one word which is commonly used in economics is the laissez-faire. I think this laissez-faire also is something which the people in other disciplines and especially in planning, they also like and they go with it, because they do not require to do any new things. And it is always better कि ये पहले से चलता आ रहा था, so that we did not do anything, so that even if there is a failure, so there is no blame on you. So basic issue is the issue of the accountability, and we don't want to be shown responsible for anything. And then determining and rectifying complex planning process, and also save time, and what you can say, the attaining the balance in requirements of urban and rural area, and then we can say the increasing public involvement, and we can say the ensuring sustainability in the plans, because there are certain plans which are implemented but the lifespan is too short. What we require over here to make it sustainable, and adopting global standards for public engineering and architecture, and offering implementation. We can say offering implementation of guidelines based on internal standards of planning, and then connecting, learning, and collaborating. I think this is one of the common feature that we find over uh, the different countries, different disciplines, that it is required to collaborate in a, not only in planning but also in, we can say, academics or in any other research activity. You can say there is Indian space research organizations, how they are using this geospatial technology for rural development. We can say the geospatial data that is generated by ISRO, that is something which has been and shall be used by the government for planning services. Before I actually say anything on it, I just want to mention one more thing over here, that earlier, long back, I think before 2005, somewhere in 2003 or 4, the then president, Dr. APJ Abdul Kalam, visited NRSA, Hyderabad, which is now known as NRSC, National Remote Sensing Center, which was earlier National Remote Sensing Agency. He visited there, and the scientists of NRSA of ISRO, they showed many of the things to pertaining to the land use, land cover type of things to the then president. And all of a sudden, the president asked that how much is the wasteland in our country. Then, including chairman, all such scientists who have been dealing with different aspects of the remote sensing, they were unanswered. They had no answer for it. And then president said that what is the use that you are talking about so many such satellites that you have for remote sensing, having different spatial resolution, and you are getting the real-time data. But if we do not know that how much is the wasteland in India, what is the use? And then after his visit, the or what we can say after that particular issue, that the wasteland atlas of India has been prepared by NRSA ISRO. I think this is one of the things that we can say many such issues, or over here, I can say one thing that mostly planning in our country is reactive. Whenever we require certain things, and then only what you can say it was a hit and trial type of things. Whenever something is required, the people start doing that thing only thereafter. And same thing happened with us, our planning, whether a new school is to be opened or whether new college is to be opened or any other things. I think this was always which was done on political considerations. However, if we have a clear cut idea and the database, I think that can certainly help in planning. Why I'm saying help? Because any of the software that cannot force or any of the results coming out of any such technology cannot force political or administrative people to go on that line. But this is just that it helps in decision making. As if I'm not sure what are the backgrounds of all the participants, but if they have come across one terminology of geography, environmentalism, and possibilism, and when we say the possibilism, it does not drive people on a particular path, but it gives you numerous possibilities and out of which you are free to choose. So is the case over here that the geospatial technology, it gives you various scenario and it is for the planner, it is for the political bosses, and it is for the administration of the day to choose anything out of it. We can say that this data, it can be very useful in rural planning, especially as I've been mentioning about the schools and any other government services. I think when Chandra Babu Naidu was the chief minister of Andhra, I think he was the first chief minister, at least in India, who was taking help from uh, the people who were trained in this geospatial technology. He used to get some idea for any new activity, any new centers which is to be opened. Otherwise, what has happened? Many times, certain schools and colleges have been opened in an area where there is no feeding area. I see here in Himachal Pradesh that certain college has been opened just because of political consideration, but where the people or where the students will come in. Because in college, we get the students after 10 plus 2. If there are no 10 plus 2 within the hinterland of that college, and if the population is not enough, then why should it have been done? This also happened in many cases. If there is no threshold is met, I think all such activities, they are closed down or they remain in a very what you can say, in a very underutilized manner. That has been one of the case. And we can say the space-based information support for decentralized planning, SISDP. This is one of the effort which is very important, and what is required to decentralized, and therefore the regional centers and project director. They say the ISRO and Ministry of Panchayati Raj are working on creating an ecosystem for using high resolution thematic data for better planning. If it happens that Ministry of Panchayati Raj, which is responsible for many of the activities in rural area, rural development, and if we can certainly make use of the high resolution data with its thematic category, that can be certainly very useful for the better planning. I think you'll be aware of one thing, which was that Tata Nano Factory, when it has to be established, and there was a lot of there is there was a lot of hue and cry in West Bengal when Tata was supposed to establish its nano factory in West Bengal, and after the farmers whose land was taken over for setting up of the industry at that point of time, and there was a lot of hue and cry. And finally, what did happen that the present Prime Minister, Shri Narendra Modi ji, who was Chief Minister of Gujarat, he offered that you come to Gujarat and establish nano factory over there. And Gujarat was the first state who have established BISEC. Any center which make use of geospatial data, BISEC was the Bhaskara Institute of Spatial Application Center. And as a result, they were given 1 week time to identify the land for Tata Nano Factory, identify one, and the then director of this BISEC, who visited after some time to Shimla for some lecture, and I heard his lecture and I was really impressed about one thing, that how geospatial technology is useful in making such decisions. That however, he was asked to identify one patch of land for nano factory, but using the geospatial technology, they showed 3 different sites, and the people who were there from Tata site, they saw all these 3 location on screen, and they liked one and they visited that, and the MOU was signed within a week and the factory has been established. So this is how the geospatial technology, it become useful. Then we can say here how this geospatial technology, we have several such examples in rural development. I just mentioned about wasteland mapping, which was done for whole of the country after the visit of the Dr. APJ Abdul Kalam at that point of time. And there is also the watershed soil and water conservation. This was another project which was taken at all India level, for which various activities and various things that was required, it was done. And then Rajiv Gandhi National Drinking Water Mission, which was initiated in 7 dry states. And the result of this drinking water mission was with 90 to 95% success. Idea was especially that in some of these states, when tube wells and other things they were done, they were what you can say dug over there, and earlier success rate used to be just 50-50. But here it so happened that since the rock characteristics, soil characteristics, the vegetation, the other things, they have been very well studied earlier by the use of the remote sensing data, so that the success was 90 to 95%. And likewise, all these smaller, what you can say, soil, water, and other things, this monitoring of all water bodies, how whether they are expanding or shrinking, that has been also done in various parts. And also for the forest types and biodiversity, we have a different types of biodiversity. India is having a rich, or you can say the hotspot from biodiversity point of view, and which has been very well studied and done through the use of the remote sensing data, or you can say the geospatial technology. And here, 2 examples of the latest schemes, which is the rural assets monitoring for Mahatma Gandhi Narega mission. इसमें क्या हो रहा है कि अगर आप देखेंगे कि जो बेनिफिशियरी है महात्मा गांधी नरेगा के तहत, और दूसरा राइट साइड में आप जो देख सकते हैं कि देयर इज प्रधानमंत्री आवास योजना, which is the people are helped for their new construction house who are homeless, and under this the person who these houses are allotted, they are also geotagged. And how geotagging has become very important in today's time. Even you see that all the animals, whether it is cows, bulls, buffaloes, they are also tagged on their ear. Likewise, you see that the geotagging of the person who was allotted house was very important, because earlier what used to happen, the person who have been allotted these houses, वो क्या करते थे, उसको किराए पे चढ़ा देते थे और खुद एक नई झोंपड़ी बना देते थे, और उस तरह से ये एक सिस्टम चला हुआ था। तो अब जब ये जियो टैगिंग हो गई तो निश्चित रूप से वो जो अलॉट हुआ मकान किसी का भी, it is geotagged, or there is a person's photograph and his vital detail or her vital details, including their Aadhaar number or any other information that is tagged with it. So this is very useful. Just hold on. Anji. क्या हुआ होगा, वो टाइम तो उनका आज का ही था। आपके पास नंबर है उनका? अच्छा, पता नहीं है, तो वो मीटिंग में तो थोड़ा देख लो और क्या करना। जस्ट होल्ड। Excuse me, friends, I just have a important call, because my other course is also running at the same time.
No issues, sir.
और वो एक्चुअली क्या होता है कि कभी कभी ऑनलाइन में और मुश्किल हो जाता है, जो हमारे वहाँ के रिसोर्स पर्सन थे, he has not joined, so okay, finally he has joined. So I've been just mentioning about the rural assets, and in rural assets, so what used to happen, पहले जो अगर आपको ध्यान होगा, हमारे रूरल एरिया में क्या होता था कि लोगों के नाम लिख लिए जाते थे। कभी कभी काम पे और उसमें 4 ही लोग हो तो उसमें 1-2 और एक्स्ट्रा लिख लिया जाता था, लेकिन नाउ in order to bring in better transparency and in order to have the what you can say, the real benefits goes to the actual people. For this, the geotagging has been done, and these are the two just example, Awas Yojana and Manrega, where it has been done very successfully, and that has certainly brought in more transparency, and it is proving a very good tool in rural development. Likewise, there is also for urban area. In urban development, we can say the Amrut is one of the program that you all know, that geospatial technology, and in today's time we can see that earlier it was Jawaharlal Nehru Urban Renewal Mission, and now we have been following the Smart City Mission after this, and all these are the new names, but basic idea is to have a sustainable development planning of any city. What you can say, the making use of the technology in urban area, different type of in smart city mission. What is smart city? That initially many of the people or many of the youth, they were just thinking that the smart city means that there are free Wi-Fi. But this is basically using the decision support system, DSS, which has been very useful, and where we use very high resolution satellite data, and then actually see the outcome of the planning in those areas. And in smart city mission, this has been done, that how the this geospatial technology can be used. I can just mention two, three things in smart city mission, that it's just not the providing the free Wi-Fi things like that, but we can have a very high resolution monitoring of the roads and streets through satellites itself, which will certainly reduce the crime and things like that. In future, probably we may not require to place the so many CCTV cameras, because many of those things that will be monitored through the radar, drone, and some high resolution other satellite data. And apart from this, you'll see, for example, in any of the urban cities or in urban areas, you see that many of the things, as I was just looking outside over here in Shimla, कभी कभी वो जो street lights है वो रात को तो ठीक है, दिन को भी नहीं बुझती है. I think, can we really use the geotagging system that in control room we have the complete monitoring of these things, that still the lights have not been switched off, so that there can be some either automated system, as in cars we already have that system. When it gets dark, then if the your headlights are on auto mode, they will switch on automatically, and when it is bright, they will be off automatically. If it happens, what actually will happen? एक तो वेस्टेज बचेगा, जब वो पूरे दिन में ब्राइट सन में भी जो है बिजली जल रही है. दूसरी चीज कि if even during the day sometime it gets dark just because of the bad weather, then the lights will be switched on. Otherwise, manually people don't switch on the lights during the day. I think in Rajasthan or in any of the areas, sometimes it gets all of a sudden due to certain thunder, sometimes it gets very dark. And during the middle of the day, you'll have a feel that it is almost something closer to the night. In that case, that will be very useful. And third thing that I came across, that we can have some automated system through geotagging for garbage. When the garbage dumper is full, so that in your control room tagged with this GPS, there will be the red lights that this garbage dumper is full, so it needs to be cleaned or it needs to be changed. I think that kind of thing will be very important. And in disaster supports, obviously, floods, forest fires, cyclones, landslides, many of the agencies, they are working on it. And now, because time is less, I'm just coming to the case study which we did. Especially, I'm thankful to Ajay, who is working on it, and I acknowledge his contribution over here. You can see the idea is to have the soil status and soil loss characteristics of that block, development block. And this is the Rodo development block where we worked. And mapping of land use, land cover, and capability of steady area, and to analyze the impact of apple cultivation on soil and environs. And as far as methodology is concerned, that both primary as well as secondary data has been used. As when it comes to secondary data, there is the geo-referenced map preparation and the topo sheets of the Survey of India, and satellite image DEM, Google Earth images, and then National Bureau of Soil Survey, land use planning, the data provided by them, and create the different database. And as far as the primary survey was concerned, it was the field-based survey through GPS, and also certain other instruments in which this instrument in which the pH value and some of the other characteristics, they have been done in the field. And then all these have been put together to understand the land use, land cover change, and the soil loss equation and land capability, and then see for the final result and discussion that what we can get over here. This is the study area. This study area is the Rodu CD development block, which is one of the community development block of district Shimla, Himachal Pradesh. These are, of course, its geographic locations and extension, which I'm not going into detail, but it has 188 villages in this, out of which 170 are inhabited and 18 villages are uninhabited, where there can be some population sometime. And there is a population of around 56,000 as per 2011 census. And what was the idea that we can say that the different maps, as you can see, the generation of a database, that different layers have been, or different maps they have been prepared. Apart from relief, there was slope, aspect, drainage, and what land use and soil taxonomy. All these different layers they have been prepared, they have been created. And after this, we can say how we can say this geospatial technology for soil resource monitoring, because it is the soil is the vital resource over which all other activities, whether we do agriculture, horticulture, or other things, they certainly lie on it. And for this, National Bureau Soil Survey in Nagpur data has been used. And over here, apart from this, there is also Krishi Vigyan Kendra, Rodu. They also provided some data. These are the soil types in this area as per the classification of the National Bureau of Soil Survey Nagpur. These are the different categories we can see over here. And then there was also the soil depth. We can say there is a very small area which you can say the deep soil, which is the darker, and larger area that you can find is either in the medium or there is a shallow soil, because this is a mountainous area and soil has not really what you can say has not been very deep over here. These are the soil testing sites, all these locations which have been done in the field survey by Ajay, visiting all these locations for soil testing. Then the soil pH, you all know that the value it varies from 0 to 14, whether the soil is acidic or alkaline. These have been done in whole of these area. And you can see over here that there are many, this yellow, it has the yellow and this orange and the red. It has what you can say the most of the area that you can see as far as the pH value is concerned, they are fine, or they are suitable. Then soil or organic carbon, again, we can find that there are the three different major categories over here. And then soil temperature, you can say some of the areas which you can say are red, they have the temperature, higher temperature, but the lighter will have the lesser temperature. Then soil nitrogen. This area has also the rich in soil nitrogen. And then soil phosphorus. Again, you can say half of the region, it has either the normal or you can say a bit more, but at the same time, this bluish, it has the lesser phosphorus characteristics. And then soil potassium. This has all these things have been done through soil testing lab after taking out the samples at different locations, nearly 200 locations. Then as a result of this, we can see the overall soil fertility and how after putting all these layers, which is only possible in geospatial technology, that we got as far as the pH, there is also the villages which can be put together into low, medium and high category villages of the different. And as far as the organic carbon, they have been also put into these three, low, medium, and high category, and villages have been identified out of these 170 villages. And likewise, there is also nitrogen, phosphorus, and potassium. And thereafter, a nutrient index for overall that has been calculated as per the methodology used by Parker et al. In 1951. And that will give you the idea. And you all know in the soil erosion estimation, earlier there used to be the USLE, which was the universal soil loss equation model. Now it has become a RUSLE, which is the revised universal soil loss equation, in which we take many of these things like topographic, soil erodibility, and rainfall. And here you can see for the whole of the region, as far as the different characteristics are concerned, there is also rainfall erodibility, there is also soil erodibility, and there is also slope length and slope steepness and land cover management and conservation practices. All these have been considered, and we can say the average annual soil loss has been calculated by taking into rainfall erodibility, soil erodibility, and topographical factor, which is slope and steepness, and then land cover management factor and conservation practices. All have been taken together. And for this, we can say there is a soil loss risk, which has been calculated. And you see most of the area that lies in red, which has a very high soil loss risk, and which is bit yellowish in the valleys, you can put it into middle category. So as far as the soil loss, because of the shallow depth of the soil, because of the high slope, steep slope, and also at the same time deforestation and the agriculture practices, that has been contributing to the soil loss. And then there is also the land capability classification, which has been also done for the various categories. We can say this green one is suited for cultivation, and the other categories, which include the yellow, which also include the red, or which also include the other color, they are not suitable for cultivation as per the land capability classification. But as we saw earlier, when we have been looking about the land use and land cover also, the cultivation has extended over even on those areas which are not suitable for cultivation because of not only pressure, but also the greed, and also probably as the people are getting a good return from horticulture crops that has been done. And therefore, the land use land cover, this is a land use and land cover of 2002, which was used for which the Landsat 5 thematic mapper and ETM plus of Landsat 7 that has been used. And we can see very distinctively over here, the darker green is the forested area, dense forest, but this light orange color, this is all the plantation has extended. Because in Shimla district, you all know the apple cultivation is one of the things. And this category, if you can see over these categories, this is the wasteland, and especially these are the area which are the steep slopes and mountainous or the snowbound. So these are some of within these, in the plantation area, we can find the red spots, which is the settlement in these area. And then this is the land use land cover of 2010. As I mentioned that for this Landsat 7 has been used, and you can see very clearly in these two maps that plantation has increased plantation area has extended over the even forest area and also in the wasteland. And there is land cover of 2018, which has further increased. For this, you can see in land use land cover for which we used a high resolution data, which was of about 5 meter. And here you can see very clearly that there is a shrinking of the forest cover as the plantation has gone further. And as a result, if we take agriculture and horticulture, agriculture, some of the small patches in yellow, but the another one which is darker yellow is all horticulture, which are especially in case of rural development block. This is the apple cultivation, and this agriculture area you can say has shrinked while the plantation it has gone up. You can see from these vital statistics that of the total geographical area, nearly 50%, or in this case exactly 46% is the plantation. There is a not 44% is the plantation. And if we take together agriculture and horticulture, this is nearly 50%, and remaining either it is the wasteland, mountainous area, or it is some forest which has been left. And after bringing out all these categories, they have been overlaid with that of the Google map. And this Google map, that there is a cultivated land and relief relationship we do find. And you'll see that overall elevation of the area, it ranges from nearly 1300 meter to 3400 meter. So we can say there are several categories. And what has been actually done, that how it helps in planning, that what actually we are doing of what land. It's not only that, because that will be certainly whether we are extending the agriculture on a very steep slope, there will be certainly the soil loss, which will be more. And at the same time, uh, the cultivated land on a very other, which we have seen earlier category, whether the land capability is not good, but still it is cultivated, though certainly there will not be any good results as far as this. Then there is a cultivated land and soil characteristics. On the basis of the soil characteristics, as I said, that whether it is neutral, whether it is slightly acidic or moderately acidic, or in case if it is alkaline. But in case of our study, there is most of the land that is in neutral or maybe acidic. So there is no alkaline because in mountainous area we don't find much having more than 8 pH value. As if we will do it for Punjab, we'll find more of the alkaline, where there have been a lot of irrigation and waterlogging condition. So we do find the pH characteristics of the soil, and then when cultivated land and soil nitrogen, then cultivated land and land capability, then finally the soil loss due to apple cultivation. This revised urban soil loss equation, we do find there is a high risk of soil loss due to elevation, steep slope, and rainfall, and moreover the land use which have been practiced in those areas. There is a very high chances of the soil loss. And then apple cultivation, it also make the soil more vulnerable to erosion. Then more than 70% of the total cultivated land falls under high to extensive soil loss category, as it has been already mentioned. And crop diversification and multi crop farming, that has become a thing of past, because now it has gone to monoculture. And therefore we can say Agriculture is certainly, because when we are planning for the rural development, we cannot leave agriculture. So it is the key indicator. And unsustainable agriculture practices, as I mentioned, that unsustainable, that we are doing it on higher slope, and we are uh, generating or doing some cropping system which is not suitable for those land category, that all become unsustainable. It can generate good financial output for a short period, but certainly have telling impact on soil and environment. We have several such examples, even that of Green Revolution, which brought in prosperity in the beginning, but after 60, 70 years today, we see that all those areas, they are lagging behind. There is a shift from traditional agriculture practices to monoculture, and in case of this study area, it is, you can see in our Shimla, this is what? This is the apple cultivation, not even the different type of uh, other horticulture practices. And there is an increased inclination towards apple cultivation, which has resulted in the forest land encroachments. In this Rodu development block, there have been several such news in the past that people have extended their apple cultivation in the government land, और सरकार ने जब कुछ समय पहले एक ड्राइव चलाया था हाई कोर्ट के उस पे, तो बहुत जगह पे जो full grown tree थे, they were also slaughtered due to this thing, because they are on the forest land. So the problem of soil loss and subsurface slumping, landsliding, and this land flowing, they have been observed in several areas, some of the areas of this study region. And crop diversification can be really useful, but that is not done. And the soil of the study area is very fertile and suitable for tropical fruit cultivation, but diversification is required. So with this, friends, I'll be coming. These are some of the ideas that my scholar, that he was taking samples in the field in different area. With this, I thank you all. Thank you very much for your patient hearing. Jay.
Thank you very much, sir, for such an enlightening lecture and discussion about the land resource management using geospatial technology. It was very informative, sir. We have, sir, a few questions from the students. So the first question, the Abhishek wants to know that which sensor data is useful for soil type mapping? If you want to go for soil type mapping, so which data is useful for?
देखिए एक्चुअली वो इट डिपेंड्स अपॉन योर एरिया. अगर तो वो बहुत छोटा एरिया है तो सर्टनली सेंसर इज नॉट दैट मच important, but we certainly require high resolution data. And in case of Indian satellite data, probably because for this we'll be requiring the multispectral data. I think LIS4 data is the one which we can get at the moment. Otherwise, my scholar, he got some data free of cost, which was also on a high resolution, but it was for a very short period of time. For 15 days, they provided free window, but that will be useful. But in certain cases, maybe the cartoset data, if the area is small, if you're doing it for the larger area as wasteland mapping was done for the bigger area or this thing, then certainly we cannot go with a very high resolution data. So sensor, because in case of Indian satellite, we have the LIS, or in case of the other, they will have the other sensor. So instead of looking for sensor, certainly आपकी requirement क्या है? High resolution data, which in the range of 2 to 5 meter, that will be probably the best one which we can do.
Okay, thank you very much, sir. Another question from student that he wants to know that how can we get the geotagging data? As you discussed that geotagging is useful for disaster management. So how can we get this kind of geotagging data?
देखिए जियो टैगिंग डाटा कुछ केसेस में तो होता है, जैसे फॉर एग्जांपल यू विल गेट इन केस ऑफ डैम, जो डैम होता है नेचुरली वो ऑलरेडी जियो टैग्ड ही होता है, बिकॉज जियो टैगिंग इज समथिंग विच इज विद latitude and longitude information. But geotagging, what I've been using, for example, there was flood incident in Himachal Pradesh. So all that area which has been affected, for which we do the geo mapping, which is certainly tagged with it that this is the area which has been affected, and different agencies. आज की डेट में जो है different agencies they are doing it, but as far as the NRSC, which provides the data, they give you two types of data. One may be the raw data, another maybe the which has this geo-reference data. But geotagging has been basically used that when any of the activity, when any of the planning activities, और जैसे मैंने आपको बताया प्रधानमंत्री आवास योजना और some disaster incidents, और there may be the मनरेगा, तो उन एरिया का प्रॉपरली जियो टैगिंग करना. और जियो टैगिंग इज लाइक दिस दैट ऑल ऑफ अस हैव जस्ट वन आधार कार्ड which is unique UID. Likewise, when we do the geo tagging of those areas, there will not be this type of things कि क्या होता है कि जब कोई एक चीज को दूसरी जगह नहीं दिखा सकते हैं. That brings in the transparency and that also helps the future planning.
Okay, thank you very much, sir. Sir, another question is related to, sir, the rural and urban fringes. Means if someone wants to map the rural urban fringe, so sir, can we use geospatial data for that?
Yes, definitely, definitely. अब जैसे देखिए कि आपको मैं जयपुर का एग्जांपल दूं पहले. जो पुराना जयपुर था जिसको हम पिंक सिटी बोलते थे, आई डो नॉट नो आप कहाँ से. मैं जयपुर का एग्जांपल इसलिए दिया बिकॉज द यूनिवर्सिटी इज situated in Jaipur, so I believe that many of you are from that region. And Pink City was the old city, which was a sort of walled city, but now the present Jaipur is much, much bigger than that of a Pink City, or than that of a old city. Likewise, many of the area that you can say the fringes, or that you can say the rural or transitional zone, that is very well. जब आज की डेट में जो पहले अर्बन में हम स्टडीज करते थे पहले, जैसे जिसमें अर्बन एरिया एंड अमलैंड और अर्बन कोई सम सिटी और इट्स अमलैंड का जब हम बात करते थे, उसके बाद अब अमलैंड को कैसे हमने जिसको इनसर्कल करना है या किस तरह से उसको रिस्ट्रिक्ट करना है कि कहाँ तक जाएंगे, उसमें जो जियो स्पेशल डाटा दैट्स वेरी यूजफुल, व्हिच गिव्स यू आइडिया of the type of the activity and type of the expansion which has taken over. Different जब हम spatio temporal analysis of any city करते हैं, तो that's something. But for that I think कम से कम हमें आज की डेट में लिस्ट फोर डाटा जरूरी चाहिए. इसलिए हाई रेजोल्यूशन डाटा, और उसमें बड़ा क्लियरली आपको जो रूरल एरिया है विद इट्स लैंड यूज क्लासिफिकेशन, हमारे को चाहे वहां पे एग्रीकल्चर होगा और चाहे वहां पे किस तरह की जो डिफरेंट लैंड यूज कैटेगरीज है, उसके आधार पे यू विल हैव ए वेरी क्लियर कट डिस्टिंक्शन, because there will be more of the area under agriculture, horticulture, or things like that. There will be the different type of the settlements, but in urban area you'll have all built up area, very high rise buildings and other things, and in between I think we can certainly get this transitional type of land use practices, which will be very well identifiable.
Thank you very much, sir, for such a nice clarification. Sir, last question from my side. Sir, that you have talked about the horticulture crops.
Okay.
So, sir, if we see that horticulture crops are scattered, it's not having big patches. So, sir, how we can get it or how we can map horticulture crops if we use the satellite images?
Okay. No, it's very well. Let me tell you one more thing, which of course is not part of your question, but it is very useful. I tell you, what happened? Namaste, Siddiqui Saab has joined.
अरे
Namaste. I'm just taking
नमस्कार,
one.
गुड मॉर्निंग सर, गुड
Namaste,
मॉर्निंग,
namaste.
हैप्पी रिपब्लिक डे सर, गुड मॉर्निंग।
थैंक यू सर, थैंक यू आपको भी। हाँ, मैं आपसे ये कह रहा था कि उसको कैसे, इट्स वेरी वेल आइडेंटिफिएबल। मैं ये बता रहा था कि सम टाइम बैक इवन as far as the classification, these horticulture crops were not treated as the forest. But there was the change in the definition. Now all horticulture crops, they have been also treated forest. Or as a result, the area under forest in Himachal Pradesh has gone up, which is artificial increase because it has not actually increased. It increased just because of the change of definition. बट आप बोल रहे हो कि वो कैसे आइडेंटिफाई हो जाता है? इट्स वेरी वेल आइडेंटिफिएबल बिकॉज हॉर्टिकल्चर क्रॉप इट हैज ए वेरी डिफरेंट पैटर्न, इट हैज ए वेरी डिफरेंट टेक्सचर बिकॉज फॉरेस्ट जो नेचुरल फॉरेस्ट है इट विल हैव ए वेरी डिफरेंट टाइप ऑफ टेक्सचर, बट हॉर्टिकल्चर क्रॉप्स बिकॉज दे हैव बीन प्लांटेड at a same time, and they are pruned, they are looked after, so there will be something a very different type of pattern. जैसे कि as you can identify, differentiate between a stadium and a some open pasture, likewise the horticulture crops, they are very well identifiable from forest or from agriculture.
Okay,
Thank you.
thank you very much, sir. Thanks a lot for such a nice information on the use of geospatial technology for the management of land resources. It was very informative, and you have clarified the queries asked by the students. Thank you very much, sir. Thanks a lot.
Thank you.
Now I would like to call Ms. Priyanka for
Thank you,
inviting
sir.
our next speaker, Siddiqui sir.
Thank you, sir.
थैंक यू प्रोफेसर डीडी
Okay,
शर्मा
okay,
जी।
Siddiqui साहब,
मैंने
thank
माफी
you. See
चाहता
you.
हूँ कि मैंने कैमरा ऑन सिर्फ आपको देखने के लिए किया, और
नहीं, कोई
आपको
बात नहीं।
प्रोफेसर डीडी शर्मा जी इसलिए कहता हूँ, डी फॉर डायनामिक एंड डी फॉर डैशिंग, डायनामिक एंड डैशिंग प्रोफेसर शर्मा।
थैंक यू सर, थैंक यू। मैं बस आपके जाने के पहले इतना
Thank
ही
you, sir. Thank you,
कहना
sir. It
चाहता
was
हूँ।
very engaging and interactive session, and it was a very good presentation. Now,
Thank you.
moving forward with our next speaker,
Priyanka, wait for
Dr.
a minute.
A.R. Siddiqui.
Priyanka,
Before that, I would like to take a
Priyanka.
moment to introduce our speaker, Dr. A.R. Siddiqui, Professor and Head of Department Geography. Since 2016, he is holding the post of Secretary General, Indian Institute of Geomorphologist. He is also a member of various professional bodies with twice appointed as Dean Student Welfare. Presently, he is having responsibility of International Advisory of Foreign Student Chairman Data Cell, Nodal Officer, NIRF, ISA, and so on and so forth. He is holding the post of Senior Vice President, Allahabad University Teacher Association. He has completed his education degree from Allahabad Muslim University, Aligarh Muslim University, and has started his career from Chaudhry Charan Singh University, Meerut, in the year 1999. In 2012, he was evaluated as associate professor, and following 2015 as professor. He has completed NNRMS training course and 3 international training course programs sponsored by United Nations. He has also obtained PG diploma in geoinformation science specialization in geohazard from IIRS Dehradun and ITC Netherlands. He specializes in arid zone research, urban environment issues, application of remote sensing and GIS in land degradation study. He has supervised many PhD students and has published many research papers in peer-reviewed journals and authored many books. Professor Siddiqui is recipient of Excellent Award in the year 2018 by University of Allahabad. Now, on this note, I invite Professor A.R. Siddiqui to take forward today's program. Sir, you're most welcome.
श्रुति जी, आप कुछ कह रही थी प्रोफेसर शर्मा जी के बारे में, तो शर्मा जी के बारे में मैं एक शेर कहना चाहता हूँ, और वो शेर जो है शहरयार साहब ने फिल्म उमराव जान एक फिल्म थी, उसमें गजल थी, उसमें लिखा था कि जिंदगी जब भी तेरे बज़्म में ले आती है हमें, ये जमीन चांद से बेहतर नजर आती है हमें, और हर मुलाकात का अंजाम जुदाई क्यों है, अब तो यही बात सताती है हमें। अफसोस कि मैं पूरा लेक्चर आपका नहीं सुन पाया, लेकिन श्रुति जी ऑलरेडी रिकॉर्ड कर रही हैं, तो मैं उम्मीद करूंगा कि उसको सुनूंगा भी, और जब भी आपको देखता हूँ बड़ी ऊर्जा मिलती है सर। तो श्रुति जी कुछ कहना चाह रही थी, वो सुन नहीं पाई, तो आप अपनी बात कह लीजिए, तब शर्मा जी हमको लगता है।
थैंक यू सर, मैं लीव कर रहा हूँ और मैं इतना ही कह रहा था कि मशहूर होने का शौक नहीं है मुझे, बस आप पहचानते हैं इतना काफी है।
क्या बात नहीं, श्रुति जी कुछ कहना चाह रही थी आपको, तो
सर
इसलिए
सर मैं तो प्रियंका को इंटरप्ट कर रही थी कि 2 मिनट सर लोगों को बात करने दो, देन यू कैन इंट्रोड्यूस।
वो
अच्छा ठीक है,
प्रियंका
ठीक
को
है, तो
मेरे
मेरी
एक
बात हो
साल
गई।
है।
मैंने शेयर के माध्यम से सर को मैंने अपना मैसेज कहा सर के लिए, जो हमारे लिए रिस्पेक्ट है। तो बहुत अच्छा लगा सर आपको,
थैंक यू
आपसे
सर,
मिलकर।
थैंक यू,
अच्छा
ऑल
सर,
द बेस्ट सर।
ओके सर, थैंक यू सर, नमस्कार।
थैंक यू श्रुति।
यस सर, थैंक यू सर।
तो should I continue? I think 11:15. So I will take at least 1 hour. I will complete my lecture on 12:15, Shruti.
यस
Or
सर, यस सर।
Dr. Suraj, thank you very much. I would like to thank Suresh Vihar University, the most vibrant university of India. And I'm already observing and following you people, particularly Dr. Shruti Ganga and Dr. Suresh, and so many distinguished scholars you have invited in your university. And I'm seeing the learned, our participants are here, and they were making questions and all these things. So first of all, I would like to thank for inviting me to share some my views regarding the mapping and monitoring of land, water, and vegetation, that is natural resources. It is a very pertinent topic, but I will cover some general aspect because I am not knowing about the participant whether they belong to geography or physics or any other background. And basically, I am geographer. I am not remote sensing. I am not having such expertise in remote sensing, but I am using remote sensing and satellite data for the generalization of the some objectives of some my geographical problems. So I am basically geographer. So I will discuss dimension of climate related studies and what are the issues related to identification of visible and non-visible impact of climate change, and what are the potential of geographical studies nowadays, how geographers are shifting their orientation towards from the traditional researches to applied aspect. And I will throw some information related to impact of climate change and what are the common understanding of environment, sustainable development, because you will see and you will mark last 20 years and you will see that trend of last 30 years, and every big or major project or every big conferences which is generally you mark that there is a theme of conference is climate change, sustainable development, global warming. All these are common topic. If you will submit your major project on these issue, and definitely you will get, you will be sanctioned this the project on these common themes. So generally, why we are working from 1983 and from 1987 on these issues? Generally, mostly geographers are doing on the sustainable goal theme, and what are the common theme, whether you are from earth science background or geography background, it does not mean, but our researchers are going to shift towards the applied aspect of the society. That's why I have taken this topic to discuss the application of satellite drive data in the and remote use of geoinformation science and geoinformatics in the geographical problems. So I will discuss about drought monitoring and desertification monitoring, which is a very pertinent issue in the country. And before Corona, you might be knowing that there was a convention in Ghaziabad and Noida, and our Prime Minister Modi ji was chief guest on that conference. And after 2 months, there was a Corona. So you will see in 1977 there was a conference of United Nations Conference on Desertification, and there was a conference in 1992, United Nations Environmental Program, which was held in Nairobi, and then definition of desertification was changed, and these are the very pertinent topic to work on land, water, and vegetation. So I will discuss because I will move. I think in a so hurry manner because I have to cover many slides related to my work. So these are the dimensions of climate change. All of you, you belong to earth science or geography, does not mean. Generally, we are concerned about knowing the relationship between climate and soil. A lot of paper have been published by Dr. Shruti Kanga and Dr. Suraj on this issue. I must appreciate their work and their sincerity towards monitoring of land, water, and vegetation with reference to climate change. So these are the common issue. We have to know what is the relationship between climate and soil, and what is the relationship between climate and soil erosion, climate and vegetation, climate and forest related studies, climate and ecological productivity, climate and hydrological processes, climate and landform processes. As a geomorphologist, I can say, I can relate what are the impact of climate on landform processes. And climate and agriculture is a very burning topic nowadays. And you might be knowing the work of Dr. N.R. Patel from Indian Institute of Remote Sensing, Dehradun. Climate and urbanization, just you ask a question to Professor D.D. Sharma ji regarding the mapping of land and city region areas, and climate and tourism, relationship of climate with the transport, and climate and sustainability. Basically, these are not the topic, but this is the topic of PhD, and this is the topic of major project work. So on any theme, you can enhance your interest, and you can use the satellite data, and you can select your topic for your PhD or major project work. What are the common issues? Because we are talking about the layman, those who not belong to geography or sciences. Generally, we are seeing the reporting and news related to these common aspects. You will see the newspaper, Hindu newspaper, and you will consult any magazine, and you will find these are the common topics like melting glaciers, loss of biodiversity, rise in temperature level, sea level changes, decreasing sources of fresh water, cyclones, impact of cyclones. And during during COVID-19, there was two major cyclones. One was which was occurred in Bakhali Island in 24 Pargana district, West Bengal. Another was in Arabian Sea. And so these are the what are the impact of cyclones and loss of islands, changes in seasonal pattern, changes in coastal boundaries, ocean acidification, droughts, desertification. Particularly, I will draw your attention towards the human aspect, displacement of the population and mobility of the population from one place to another place. This is more important. If you are engaged in monitoring and mapping, you will get map, and definitely you will get map and your findings also. But this is very important to work on society, on population data, which is very important because if you are doing mapping and monitoring every day, in every month, there is a change. And after next year, if you will do your same work after 2 years or 3 years, you will find another map. So working on displacement, mobility, and societal aspect is very important. And we have to take these population characteristics on our mind, and we have to relate these human aspect with the remote sensing aspect. So study of migration, loss of attraction of tourist places, and adaptation are very pertinent topic. So before going in application of remote sensing and GIS technique and use of satellite drive data, it is very necessary to think about these aspects. So how we are diverting our interest from traditional researchers to applied aspect. Suppose you see, earlier we were doing and we were using the use of statistics in geographical problems. But now we have diverted our interest in applied aspect of the society. Earlier we were doing on measuring of agricultural productivity, we were doing a mapping of urban sprawl, and we were doing on chain detection. But we have now in any university, you see, in BHU or Delhi University or Aligarh Muslim University or Himachal Pradesh University, generally teachers are allotting topic of PhD in these aspects instead of traditional aspect like water resource management, land resource management, and land evaluation is very important. If you are working on land capability classification, so land evaluation is very important, and it is a very difficult task in Bundelkhand region or any other difficult topography. How you are going to evaluate the land It is very important aspect, because we are not having knowledge about land capability classification, and we are not having expertise in the field of agricultural geography. So how we are going to evaluate the land, and what is the suitability of land? And many paper already you have published on land suitability in terms of urban studies or agricultural studies. So these are the aspects: geomorphic processes, geomorphic hazards, disaster management, forestry and ecology, agriculture, soil, population, regional planning, oceanic modeling. In every university, whether in India or in abroad, in every conference, more than 80% paper you will find in these aspects. Now there is no role of traditional aspect. Generally, we are using statistics, of course, but with the help of GIS software. So you see, these are the important aspects, and these are the general reporting. I'm not going to make a detailed study here, because there is a coastal region have begun eroding due to a rising sea level caused by climate change. There is evidence of forest fire in next 50 years. During COVID, there was a forest fire in Uttarakhand and in Amazon forest, and there will be some in next 50 years there will be disappear of a large amount of forest cover in Amazon forest. You can take an example of Maldives. Former President Mohammad Nasheed said that we are not going to become the first victim of climate crisis. You can take an example of Alaska region, and there is lots of tourist places in these areas. There is you might be knowing about the Great Barrier Reef, Australia. So there is a degree of these areas also suffering from the evidence of climate change. And Victoria Falls. These are the general reporting of newspaper. So I'm not going to elaborate these aspects. You are knowing. So you see, in 2017 report by United States Geological Survey found that the average glacier has shrunk 37% in the past 50 years, some by as much as 85%. Most alarming, only 26 glacier as in 2017. You are working in the field, though I'm not going to elaborate this field. You see here problem of Antarctica also. But I want to discuss this thing. This is very theoretical type of thing, but this is very complex and very complex to explain the meaning of environment. Generally, we are in those who are preparing for civil services examination and they are studying in master degree. Generally, you ask question, discuss about the different type of environment system, and they are writing about the pollution, air pollution, soil pollution, water pollution. But you see, the environment is simply word. Environment means all the aggregate condition, external condition that affect life and development of the people. Generally, you put this environment work with anything. If you are working in remote sensing and GIS, and we are not having the much knowledge about topography or terrain, we cannot explain. And because as a geographer, I must say, knowing our means about lithosphere is very important. We are working in different environment ecosystem. First of all, we have to know, because the Survey of India provides topo sheet, but there are some information. And first of all, we have to know what is the characteristics of terrain, in which area we have selected, what is the unit, what is the scale, and what is the unitized scale, whether it is micro level, whether it is meso level or micro level. So simply here you see what is the meaning of environment. If you are talking about any districts, any state or whole country, so first of all you see lithospheric environment, mountain, plateau, plain, pedogenic, river and lake. But we are not knowing how many settlement concentration in northern eastern region. We are not having, we are very limited knowledge. We are knowing only capital city, but we are not going to work with the remote sensing data in northern eastern state. We are not knowing the pattern of settlement in northern eastern state. We are not having much knowledge about plateau region. We are not having much knowledge about coastal region. First of all, if we are working in the field of remote sensing, then we have to gather information, geographical information from the related place, like hydrospheric environment and atmospheric environment. Simply in the social aspect, you see here the cultural and built environment, social environment. Here it is written social environment, but to write in the field of human capital or social capital or demographic characteristics, it is very pertinent to know these important aspects. Generally, we are doing in the field of remote sensing, but we are not knowing what is the meaning of land use and land cover. We are making several legends. We are making 20, 50, 100, 150 legend to show our map. But we are not knowing, earlier we were using only very high, high, medium, low, and very low. Only 5 categories. There was a representation of density of population in 5 categories. There was a representation of production of minerals in 5 categories. There was a representation of many wheat production, rice production in 5 categories. But with the help of GIS software, we are representing our information in different categories. In the case of land use, when you will work by using remote sensing data, and if you are going to correlate with the ancillary data which have been obtained from the government offices, it is not necessary, because many scientists are not knowing about the land use, history of land use and land cover category, and they are putting fallow land, current fallow land, and old fallow land. But what is the meaning of current fallow land, and how you can correlate with the ancillary data? Is it possible your finding can be correlated with the ancillary data? Is it possible you are going to publish your paper, and how you can correlate your publication with publication of government, publication of ancillary data which can be obtained from the government offices? This is very important. डॉक्टर सूरज, आप मुझे बताएंगे कि जो हमारे पार्टिसिपेंट हैं वो हैं कौन कौन लोग हैं, मतलब ज्योग्राफी के हैं या रिमोट सेंसिंग के हैं? डॉक्टर सूरज?
हाँ जी सर।
हमारे जो पार्टिसिपेंट हैं वो कौन लोग हैं, मतलब उनका बैकग्राउंड एमटेक है, एमएससी है, या कौन लोग हैं, किस बैकग्राउंड से पार्टिसिपेंट जो लोग हैं, उनके बारे में कुछ बताएंगे? मास्टर डिग्री उनका किस डिसिप्लिन में है, ज्योग्राफी में है या?
सर दे आर मिक्स फ्रॉम ऑल द डिसिप्लिन्स रेंजिंग फ्रॉम ज्योग्राफी, mathematics, statistics. Some of them are professors, scientists, PhD scholars, NGO.
बहरहाल मैं जो लेक्चर दे रहा हूँ तो मैं मान के चल रहा हूँ अपने, जैसे मेरे सामने बहुत सारे जो जैसे मास्टर डिग्री के स्टूडेंट होते हैं उनके कॉन्टेक्स्ट में कह रहा हूँ, बहुत सारे यहाँ साइंटिस्ट लोग भी होंगे, तो इसको ये ना लीजिएगा। बहरहाल मैं ये कहना चाहता हूँ कि जो हमारा सेंसस है, लैंड यूज है, उसमें कुछ कैटेगरीज हैं, जैसे नेट सोन एरिया है, ग्रास सोन एरिया है, कल्टिवेबल वेस्ट लैंड है, अनकल्टिवेबल लैंड है, बैरल लैंड है, फैलो लैंड है, और फैलो लैंड में भी करंट फैलो लैंड है, ओल्ड फैलो लैंड है, फॉरेस्ट है। लेकिन हम लोग रिमोट सेंसिंग में क्या करते हैं कि 15-16 कैटेगरी जो नजर आता है वो उसको लिख देते हैं, जैसे लिख दिया कि फैलो लैंड। अब फैलो लैंड में भी अगर आपको कैटेगरी बनानी है करंट फैलो लैंड और ओल्ड फैलो लैंड, तो उसके लिए एक परिभाषा दी गई है। आपको याद होगा, ज्योग्राफी की स्टूडेंट हैं डॉक्टर श्रुति की, जो 1947-48 में यूज ऑफ लैंड यूज ऑफ ब्रिटेन, इट्स यूज एंड इट्स मिस यूज वाज पब्लिश बाय डडली स्टैम्प। और प्रोफेसर मोहम्मद शफी इंडिया से गए लंदन में पीएचडी करने के लिए, और उन्होंने पहला पेपर पब्लिश किया था लैंड यूटिलाइजेशन इन ईस्टर्न उत्तर प्रदेश, उस पर डॉक्टरेट किया था उन्होंने। तो ये समझ लीजिए कि जो आज़ादी के बाद तक हमारी डिसिप्लिन में जो किताबें छपती थी वो डिस्क्रिप्टिव हुआ करती थी, और उसमें देयर वाज नो एनी यूज ऑफ टेबुलेशन एंड इलस्ट्रेशन एंड डेरिवेशन, यानी सारणी नाम की कोई चीज नहीं होती थी। तो जब हमको ये कैटेगरी ही नहीं पता थी, आज रिमोट सेंसिंग डेटा में हम लोग सब बड़े बड़े लोग मतलब जैसे कि कहते हैं कि बहुत ही हमारा अच्छा पेपर आ गया, लेकिन कभी कभी जब एंसिलरी डेटा की बात आती है, आप फॉरेस्ट फायर पे काम करते हैं, डॉक्टर श्रुति का कई पेपर मैंने देखा, लेकिन बहुत सारे डेटा जो गवर्नमेंट का होता है और जो बहुत सारा डेटा जो हमारे साइंटिस्ट पब्लिश करते हैं, पर्टिकुलरली लैंड यूज एग्रीकल्चर से रिलेटेड, तो वो कोरिलेट नहीं होता है कि फैलो लैंड इज लेफ्ट फॉर द रिकूपमेंट ऑफ इट्स लॉस्ट एनर्जी for the period of 1 to 3 years, it is known as current fallow land. If the land is left for the recoupment of its lost energy for the period of 5 to 6 years, it is known as fallow land. अब ये कौन बताएगा रिमोट सेंसिंग से कि कौन सी जमीन किस इलाके में कितने सालों के लिए छोड़े गई और आपने उसको फैलो लैंड की कैटेगरी में कैसे रखा, बैरन एंड अनकल्टिवेटेड लैंड। तो एनआईसी का डेटा होता है और डिस्ट्रिक्ट इकोनॉमिक्स एंड स्टैटिस्टिक्स जो डिपार्टमेंट होता है, डायरेक्टरेट ऑफ इकोनॉमिक्स एंड स्टैटिस्टिक्स राजस्थान में जयपुर में है, वहाँ का डेटा बहुत अपडेट होता है। अगर आप जाएंगे वहाँ का डेटा से अपने काम करेंगे तो वो कभी कोरिलेट नहीं होगा। तो रिमोट सेंसिंग के साथ ये प्रॉब्लम रहती है, आप 50 लीजेंड बना दीजिए, आपका मैप तो तैयार हो ही जाएगा। यहाँ पर बात दूसरी मैं कर रहा हूँ, यहाँ पर मैं पहले इन्वायरमेंट की बात कर रहा हूँ कि अगर हम रिमोट सेंसिंग में काम कर रहे हैं तो हमको हमारे टीचरों ने ये बताया गया विदाउट ग्राउंड ट्रूथिंग। जैसे प्रोफेसर शर्मा जी से आपने बड़ा सवाल किया हॉर्टिकल्चर को कैसे पहचानेंगे, प्रॉब्लम यहीं पर आती है कि चाय के बागान है, उसके बाद में खेत है, उसके बाद हॉर्टिकल्चर है, उसके बाद जो स्कैटर्ड और फ्रेगमेंटेड जो चीजें हैं, अगर आप उसमें ग्राउंड ट्रूथिंग नहीं करेंगे, जीपीएस लेके नहीं जाएंगे, पॉलीगन्स नहीं बनाएंगे, एरिया ऑफ इंटरेस्ट एओआई लेयर नहीं बनाएंगे, तो वो बड़ी मुश्किल सी चीज होती है। कभी कभी बहुत सारी इंफॉर्मेशन हम उसको मिक्स कर देते हैं। लेकिन उसके भी अलावा मैं कोई बात करना चाहता हूँ, उसके अलावा मैं बात करना चाहता हूँ कि एज ए जोग्राफर पूरे नॉर्थ ईस्ट इंडिया में हमको केवल कैपिटल सिटी के कंसंट्रेशन ऑफ पॉपुलेशन के बारे में पता है। एवरीबडी इज नोइंग द कैपिटल ऑफ मेघालय इज शिलांग, but which one is the second largest city in Meghalaya? Everybody is knowing the Itanagar is capital of Arunachal Pradesh. Which one is the second largest city of Arunachal Pradesh? Tripura, Agartala. Which one is the second largest? We are not knowing about the ordering of the city and many other places. Likewise, we are not knowing about the geographical features in any part of the country. So, in the remote sensing, I think from my point of view, 75% concentration should be towards ground truthing instead of modeling and mapping, because लास्ट में कोई सवाल जब पीएचडी में होता है तो यही पूछा जाता है कि रिलेवेंस क्या है, प्रासंगिकता क्या है। तो ये मेरा मैसेज है, कोई मैं एक्सपर्ट की उससे नहीं कर रहा हूँ। बट यू सी हियर इन द लास्ट स्लाइड कल्चरल कंपोनेंट, सोसाइटी, इकोनॉमी एंड पॉलिटी। तो जिसके साथ भी आप इन्वायरमेंट लगा देंगे, इकोनॉमिक के साथ लगा दिया इकोनॉमिक इन्वायरमेंट बन गया, सोशल के साथ लगा सोशल इन्वायरमेंट। So knowing environment its status is very important. But what is the area of interest of remote sensing? Nowadays we are working on hydrological modeling, watershed characterization and planning using remote sensing, flood mapping, every discipline you see here. And these are the pertinent topic and you can fill our PhD topic. Drought monitoring and remote sensing, soil suitability analysis and water harvesting, or urban hydrology and water distribution network, to ground water modeling in 2047. Because we are celebrating, our government is celebrating 100 years of our independence. On that time, you will see in the whole syllabus of geography or sciences, you will find 75 or 80% syllabus will cover applied aspect of the geographical problems. So here you see these are the common, because every layman you will ask, you are a scientist, you are expert, and you tell me what is the rate of generation of polythene, what is the rate growth of vehicles, urban housing space, loss of biodiversity, impact of extreme weather events, desertification, droughts. So it is very important. If I've taken a case study and I've seen that I have used this modeling and derivation, I got this map, it is not necessary. But what is the trend of mapping of water table heterogeneity? How many districts are under the threat of lowering of groundwater table, and what is the rate of you see an example of report of state forest report of 2019. You will find there is a as Professor D.D. Sharma mentioned that in Himachal Pradesh forest cover has grown up, but you will see in Gangetic plain, upper Ganga plain, middle Ganga plain and lower Ganga plain, most favorable geographical having geographical favorable condition. If you will compare any other place in the world, you will find Gangetic plain is the best possible condition, best geographical possible condition in Gangetic plain. But what is the scenario of Gangetic plain? You will find only 2.36% forest cover in Prayagraj. You will find only 1.38% geographical area devoted to under forest in Varanasi, and you will find only 5.48% under forest cover in Jhansi. But I'm talking in Gangetic plain, the best geographical, having best geographical condition. as compared to any other river valley civilization in the history. India covers only 2.4% geographical area in the world, having second largest population of the world. In UP, you will find 17.6% population of India, and just equal to population of Brazil. And you will find all the there are some small states, 17 states are having population just equal to UP population. To everywhere, this is a diversity. If you are working in the remote sensing and related field, we have to know all type of diversity, whether it is related with the topography or distribution of population or agroclimatic conditions. All these are very necessary to understand. If we are not understanding theoretical aspect of our problem, then what will do remote sensing? Remote sensing will give only output, and you can explain findings on the basis of output. But I think from my point of view, we have to know some theoretical aspect. Then we have to move to study about issue of sustainability. Because ecological sustainability, environmental sustainability, economic sustainability, social sustainability, and political stability or instability is very important. Because if you are having some theoretical conception in our mind, then we will do better work, because monitoring and mapping of these aspects is a very difficult task. And we always we are having a tradition. We are doing in practice these things, because if there is a day, suppose we are observing World Environment Day on 5th June, so there are different themes, and now you collect the data from internet and Google, you will find we are giving only slogan. These are the theme of World Environment Day. In 2002, there was a give slogan, give Earth a chance. 2003, water. 2 billion people are dying for it. 2004, wanted seas and ocean dead or alive. 2005, green cities plan for the planet. 2006, desert and desertification. Don't desert island. Melting. 2007, melting ice, a hot topic. 50 years back, also this topic was hot topic. In 2007, melting ice, a hot topic. You see, 50 years back, it was hot topic. Nowadays, it is hot topic. And 2008, kick the habit towards a low carbon economy. 2009, your planet needs you. Unite to combat climate change. Many species, one planet, one future. 2011, forest, nature at your service. Green economy. So these are the theme. Generally, global scientists are working on these theme. But you see, the situation, just I have mentioned, this is the real situation. If you are downloading any report and you are finding there is a worst condition, so on the basis of this situation, every scientist, every scientist, academician, environmentalist, trying to monitor what is the real scenario. So real scenario, every year there will be a change. If you are working on change detection, the main thrust area of geographer or observer or any scientist to detect the change, whether it is related to drought or desertification or land, water, vegetation or any aspect. You see, I will suppose I'm working on droughts. So there are 3 types of drought: meteorological drought, agricultural drought, and hydrological drought. You might be knowing if the deviation of if there is a deviation of rainfall from its normal value, if there is a evidence of continued deficiency of moisture, then it is called drought. And there are 3 types of drought. If the deviation of rainfall is more than 75% from its normal, it is called severe meteorological drought. If the deviation is more than 50% from its normal value, it is called moderate drought. If the deviation is 25%, it is called slight meteorological drought. Another drought is agricultural drought. Occurs when the rainfall and soil moisture are inadequate to meet the water requirement of crop. I will mention, because there is a data available water holding capacity of the soil, and you can get the data from NBSS, National Bureau of Soil Sampling, which is located in Nagpur, and which is very important and very difficult to get data of AWST. And it is also very difficult to get data of evaporation. So these are the two data which is very difficult. And what is the presence of water content in top layer of the soil? Because 25 centimeter layer of soil, what is the scenario of presence of water in top layer of the soil? What is the scenario of presence of water content in 50 centimeter of profile of soil? And what is the presence of water in 75% layer of the soil profile? So these are the important aspects. Likewise, hydrological drought, there is a evidence of lowering of water table, and like socioeconomic drought, demand for an economic good passes ahead of its supply due to weather-related deficit in Karkram. So these are the satellite drive drought indices. You all are already working. I have seen some paper published by Dr. Kanga and Dr. Suraj using NDVI, VCI, and TCI, VHI, TVDI. So I'm here recommending the work of Tucker, which was published in 1979, and they used about the normalized difference vegetation index, NDVI, and there is a work of Tucker and Chaudhary in 1987 using NDVI derivations. And if there is a NDVI range between -1 to +1 with positive value for vegetation and negative value for non-vegetative areas. These are the basic of remote sensing. But earlier we were using about the data which have been obtained from the Indian Meteorological Department. And in the case of Rajasthan, you will get a paper which was published in Geographical Journal Review, I think, work of Dr. M.S. Krishnan, and he worked on rainfall, coefficient of rainfall in Rajasthan, and he used data of 80 years, and he used a statistical technique. There was a coefficient of variation in each and every tehsils of Rajasthan. So earlier we were using data of rainfall, and we collect data from IMD, but there is some problem. If there is a data missing and for a period of 20 years and 30 years, and you will find the data is discrete. So now there was a method to calculate what is the which area is having fragile condition, like aridity indices, means the potential evaporation minus actual evaporation divided by potential evaporation into 100. And we were using the Penman's formula for the mapping of aridity areas, like non-arid region, mild arid region, moderate arid region, and severe arid region. And this map you can download from the internet. This is very important because this shows the probability of occurrences of severe drought, probability of occurrences of moderate drought. So this is very important map because our scientists are doing, and they are making the occurrences of probability of natural disasters, whether it is related to flood or drought. So these are the impact of droughts. For those students are preparing for civil services examination or competitive examination, if you ask question, how you will calculate moisture stress, it is very difficult. How you will calculate moisture stress in any area? So here it is written in theoretical form. लेकिन अगर कोई आपसे कह दे कि मॉइस्चर स्ट्रेस को कैसे कैलकुलेट करेंगे, तो आपके लिए बहुत बड़ी दिक्कत हो जाएगी. अवेलेबल वाटर होल्डिंग कैपेसिटी AWSC का डेटा, अब जमीन के टॉप लेयर में नमी की मात्रा कितनी है. कृषि वैज्ञानिक को ये बताना है कि आने वाले दिनों में गेहूं का, चावल का, रबी क्रॉप का और खरीफ का उत्पादन कितना होगा, प्रोडक्शन कितना होगा. तो प्रोबेबल प्रोडक्शन पोटेंशियल के बारे में बताना है. ये कुछ सिर्फ मैपिंग की बात नहीं है कि फॉल इन एग्रीकल्चर प्रोडक्शन कितना होगा, उससे माल न्यूट्रिशन, इल हेल्थ, डेप्थ, कर्ज, माइग्रेशन, जानवरों का, इंसानों का कितना होगा. ये सिर्फ मैपिंग का पार्ट नहीं है रिमोट सेंसिंग, बल्कि उसकी एनालिसिस का पार्ट है. सिंथेसाइज हम चीजों को करते हैं, बाद में प्रिडिक्ट करते हैं, बाद में बताते हैं. तो वो चीजें ज्यादा इंपॉर्टेंट है रिमोट सेंसिंग. पेपर तो छपेगा ही, आप 10 पे 10 इमेज निकालिए, 10 आउटपुट निकालिए, पेपर छपेगा. लेकिन वो कौन एक्सप्लेन करेगा? लॉस ऑफ लाइफ स्टैक, pressure of livestock population on limited pasture land, fall in agricultural production, reduced income, कर्ज होने वाली घटनाएं, कोई किसान फांसी लगा रहा है, ले रहा, सुसाइड कर ले रहा है, कोई कर्ज में दबा हुआ है, कोई कुछ है, बहुत सारे एस्पेक्ट आते हैं. तो ड्राउट इंडाइसेस मैंने कहा, these are the categories: meteorological drought indices, hydrological drought indices, agricultural drought indices और remote sensing data drought indices. meteorological drought indices में rainfall anomaly index में आप काम करते हैं. There are some other indices like Palmer drought severity indices, Balme and Mole drought indices, and drought severity index, standardized precipitation index, effective drought index, and Reconnaissance drought index. So these are the some references. Those who are working in the field of, suppose you remember the work of Van Rui, which was published in 1965. The rainfall anomaly index was the most popular and basic meteorological drought index in earlier days. It is completely dependent on long-term meteorological rainfall observation. So rainfall anomaly index shows the relation between a regional humidity index and the actual evaluation of dry period during the rainy season. अब आप ये बताइए कि नॉर्मल अवेलेबिलिटी पीरियड ऑफ वाटर, मानसून के टाइम में कितने दिनों बारिश हुई और कितनी हुई, कितने दिन बारिश हुई. नॉर्मल अवेलेबिलिटी 39 दिन हुई, 35 दिन हुई, 25 दिन हुई, 15 दिन हुई और कितनी हुई. तो पहले जो रीजनल ह्यूमिडिटी इंडेक्स, जो आपका आर्द्रता सूचकांक, प्रादेशिक आर्द्रता सूचकांक निकालते थे, ये देखते थे नॉर्मल अवेलेबिलिटी पीरियड ऑफ वाटर कितना है और सारी चीजें. पाल्मर ने वर्क किया, सबसे ज्यादा पॉपुलर है स्टैंडर्डाइज्ड प्रेसिपिटेशन इंडेक्स और पीडीएसआई. ऑलरेडी आप काम कर रहे हैं. तो पाल्मर सेवरिटी इंडेक्स 1965 में इट वाज डेवलप्ड बाय पाल्मर फॉर मेट्रोलॉजिकल ड्राउट असेसमेंट एंड यूजिंग precipitation, evapotranspiration and soil moisture condition as the key input. So supply and demand concept of water balance also includes evapotranspiration in the concept of calculation. तो ये भी एक स्केल को देता है और +4 और -4 में एक्सट्रीमली वेट कंडीशन, वेरी वेट कंडीशन, मॉडरेट ड्राउट कंडीशन और सेवियर ड्राउट कंडीशन को उसको स्केल करते थे और फ्रेजाइल इकोसिस्टम को बताते थे. इसी तरह से स्टैंडर्डाइज्ड प्रेसिपिटेशन इंडेक्स का भी डेरिवेशन है, उसमें भी एक्सट्रीमली वेट, वेरी वेट, मॉडरेटली वेट, नियर नॉर्मल कंडीशन और सीवियरली ड्राई कंडीशन का स्केल आपको मिलता है. उसके अलावा ड्राउट कंडीशन, इफेक्टिव ड्राउट कंडीशन, माइल्ड ड्राउट, मॉडरेट ड्राउट, सीवियर ड्राउट और एक्सट्रीम ड्राउट. So but I want to draw your attention, and you sometimes download the paper which have been published by Kogan in 1990 and 1995, and he used vegetation condition index derivation for monitoring and mapping of drought conditions, and values can be averaged spatially and temporally to facilitate comparison with the meteorological drought indices. And the work of 1995 of Coban related to temperature condition index, and he used brightness temperature maximum and brightness temperature minimum, or the smooth weekly brightness temperature multi-year maximum and multi-year minimum temperature for each grid cell. So these are the some pioneering work which have been done by Kogan and Sandhold, and he used about the temperature, vegetation, dryness index. Dr. Shruti is having expertise in this mapping and modeling, and application of Sandhold in temperature, vegetation, dryness index. So you see, this is very important issue to work on the soil moisture in agricultural drought indices. And what is the soil moisture monitoring is generally a superior acuity mean for agricultural drought assessment than precipitation, mentioned in the Food and Agriculture Organization report. And you see, the only precipitation is not that the good indicator for assessment of agricultural drought because of variable water supply mode, irrigation from canal, groundwater, storage tank, rainfall harvested and rainfed water. So you see, these are the references. Many researchers are doing good work like vegetation drought response index by Brown and Whittle. And there are some other Indian scholars also, Kogan, Wang, Kundu, Dipanita Datta, Muhammad, Professor N.R. Patel, Ganesh, and these are the references: Kogan 95, 2000, Sealer, Wang, Mondal. So these are the references, and you will find a lot of work related to drought modeling. by using vegetation health index, NDVI, VCI, TCI, and you will put the derivation, and you will download the data, even Landsat data, Modi's data, and you can do a lot of modeling. But what is the basic thing? The basic thing is to collect the ancillary data, to know about what is the trend of frequency of natural disaster, whether it is related with the flood or drought. So you see, once in 3 years, once in 4 years, once in 5 years, occurrences of major disaster, whether it is related to flood or drought. Once in 5 years, ट्रेंड क्या है उस ड्राउट का या बाढ़ का, उसके बाद पहले एक बेसिक मैप बना लीजिए, उसके बाद ही रिमोट सेंसिंग में हाथ लगाइए. उसके बाद जो मटेरियल मेथड से मैंने आपको बताया है कि आप चाहे वेजिटेशन कंडीशन इंडेक्स से लेके जाएं, if the value is ranging from 50 to 35%, it indicates the drought condition. If the value is below 35%, indicates severe drought condition. Likewise आप उसकी मैपिंग कर सकते हैं. लेकिन यहाँ पर बताना हमको ये है, ये क्रॉप यील्ड एनोमली जो ट्रेडिशनल मेथड था, हम ना भाटिया को कोट कर रहे हैं, ना हम जसबीर सिंह को कोट कर रहे हैं, ना प्रोफेसर मोहम्मद शफी को कोट कर रहे हैं, मैपिंग करके दे रहे हैं. बट हाउ यू विल एक्सप्लेन in which area there is a stress of there is a fragility of ecosystem, and in these places what is the condition of production of crop, वहाँ की उपज में क्या वेरिएशन है. तो उसके लिए कुछ मेथड्स हैं जिसमें आपको ये बताना है कि यील्ड एनोमली इंडेक्स भी निकालना है, लॉन्ग टर्म एवरेज यील्ड के आधार पे और क्रॉप यील्ड के आधार पे कुछ स्टैटिस्टिकल टेक्निक भी यूज करनी है. उसके आधार पे आपको उपज में उत्पादन में पाई जाने वाली विभिन्नता, जैसे WY यंग का काम है 1963-65 में, और उन्होंने लेवल ऑफ एग्रीकल्चरल प्रोडक्टिविटी निकालने के लिए जो किसी भी जिले में निकालना चाहते हैं तो ब्लॉक का रेशियो तहसील के संदर्भ में और तहसील का रेशियो जो है जिले के संदर्भ में, उसका एक फार्मूला है, उससे निकालते हैं. तो लाइकवाइज क्रॉप यील्ड एनोमली, all these aspects are important. Simply mapping is not important. Likewise, you can correlate with yield anomaly index, crop yield anomaly index with rainfall anomaly index, and you can make a relationship, and you can detect the information for the different years. I am moving fast because there are some more information, and on the basis of spatial temporal characteristics of vegetation, you can detect the information for every month, and you can compare for every SPI and for SPI on effective drought index or Palmer PDSI, and you can compare which method is relevant, which method is suitable in your study area. And likewise, you can make an analysis on drought modeling. So for me, it is very important to take into consideration some other important thing related to drought. If you are working on drought, you will get map, but you will not get what is the condition of level of agricultural productivity in that particular area. But you see, this is my work. I have taken several indicators, but only 5 to 6 indicators I have taken here to show some work, because there were 36 indicators for monitoring and mapping of desertification in any particular area. This project was from IRS Dehradun, and I have taken only one district for submission of my project. So in 2016, there was a atlas on desertification submitted by the great geographer of the country, Professor RS Sharma, with the IRS team in 2016, and atlas was published by ISRO. Now you see how we can we can do our work related to the desertification aspect. Drought is different from desertification, because drought is, there is deviation of rainfall from its normal value, but there is definition of desertification is different. You remember the conference of 1977, where desertification was defined: destruction and diminution of land towards arid, semi-arid and subhumid region due to adverse climatic condition. This was the definition of desertification. But this definition was changed in the year 1992. There was a conference and convention in Rio de Janeiro in 1992 of Conference of United Nations Environmental Program. Desertification again redefined, and the definition of desertification was degradation of land towards arid, semi-arid, and subhumid region due to adverse climatic condition and adverse human activities. So adverse human activities was included in the definition of 1992. So you see here what are the risk of geomorphological hazard in different land use land cover system, risk of meteorological hazard, risk of anthropogenic activities, change in vegetation fraction cover, risk of grazing pressure and intensity, risk of decline in crop yield index, just I have mentioned, risk of ground water depletion change. So these are the indicators. Simply, this is the methodology. Because Rajasthan is having district is having big area. In Rajasthan, Jaisalmer is having 38,401 square kilometer. In Churu, 13,740 square kilometer. I think Jaisalmer is 8 times bigger than Prayagraj. So you in Rajasthan, you will take average data. Resolution of average data is 56 meter. So likewise, Utah. Here you see there is the integration of vegetation, climate, and soil quality layer. On band 6 of Landsat data, you will find derivation of thermal data for the estimation of soil brightness index (SBI). अगर आपको SBI निकालना है, soil brightness index निकालना है, Landsat डेटा में band 6 में आप जानते हैं कि थर्मल डेटा. अब ये सब तो रिमोट सेंसिंग डेटा हो गया, लेकिन सॉइल डेटा बहुत ही मुश्किल है. 4-4 महीने आप सैंपल कलेक्ट करते हैं, उसको लेबोरेटरी में लाते हैं. लेबोरेटरी में लाने के बाद जो है ऑर्गेनिक मैटर, ऑर्गेनिक कार्बन और पीएच, ये सारी चीजें निकालते हैं और उसको एसबीआई डेटा जो रिमोट सेंसिंग का डेटा प्रोसेस किया है वहां पर किर्गिंग से या जैसे भी इंटरपोलेशन से जैसे भी आपको उसको लिंक करना है. इफ द इन वेस्टर्न पार्ट ऑफ रीजन if there is a fragile ecosystem and you will found low amount of carbon content, but the brightness value of image will be more. And likewise you collect soil from different land use system. एक ही लैंडस्केप में कई तरह के लैंड यूज सिस्टम होते हैं. जहां पर फॉरेस्ट है 200 किलोमीटर जाएंगे तो बबूल के पेड़ और न जाने खेजड़ी ये वो सारे मिलेंगे आपको, लेकिन आप वेस्टर्न मार्जिन में जाएंगे तो आपको स्टूंटेड बिखरी हुई घास भी नहीं मिलेगी, आपको टोटली सैंडी एरिया मिलेगा. तो हर लैंड यूज सिस्टम में जहां पर सिंगल क्रॉपिंग हो रही, डबल क्रॉपिंग हो रही है, उससे आप सॉइल सैंपल कलेक्ट करेंगे, उसके बाद टाइट्रेशन करेंगे, लैब वर्क में आएंगे. उसके बाद जो है इल्विस इंटीग्रेटेड लैंड एंड वाटर इंफॉर्मेशन सिस्टम जो नीदरलैंड ने सॉफ्टवेयर डेवलप किया है, उससे आप अगर आप काम करेंगे तो वो सॉइल इरोजन मॉडलिंग के लिए और इस तरह का जिसमें आपको डेटा को स्टैंडर्डाइज करना है 1 से 2 की स्केल में अलग अलग लैंड यूज इकोसिस्टम में अगर आप सैंपल कलेक्ट करेंगे, उसकी जो भी फाइंडिंग आई और उसके बाद रिमोट सेंसिंग के डेटा से लिंक करेंगे तो यू विल फाइंड मोर एक्यूरेट रिजल्ट. तो देयर इज ए इंटीग्रेशन ऑफ सिंपली इंटीग्रेशन ऑफ वेरियस इंफॉर्मेशन. लाइक सैंडी सॉइल है तो वर्स्ट कंडीशन है, आपने 2 स्कोर दे दिया. लोमी सॉइल है तो 1 दे दिया. और डिफरेंट लैंड यूज इकोसिस्टम ये भी आपको एंसेलरी डेटा में नहीं मिलेगा. उसमें तो आपको नेट फोन एरिया मिलेगा, ग्रास फोन एरिया मिलेगा, बैरन लैंड मिलेगा, कल्चरेबल वेस्ट लैंड मिलेगा, पास्चर लैंड मिलेगा और क्या कहते हैं फैलो लैंड मिलेगा. लेकिन जब आप रिमोट सेंसिंग पे काम कर रहे हैं तो आप ग्राउंड पे जाएंगे तो अपने हिसाब से लैंड यूज आपको बनाना पड़ेगा. जैसे ओपन ड्यून्स विद स्पार्स बुशेस एंड ग्रासेस, आपने कहा वर्स्ट कंडीशन है, देयर इज ए सैंड वर्स्ट कंडीशन, there is a forest best condition. If there is a vegetative cover appears where there is a forest appears, that is the best condition. If there is a sandy worst condition. 1 से 2 के स्केल में सारी चीजों को आपने स्टैंडर्डाइज किया. तो ये रिमोट सेंसिंग का बेसिक ये है कि इंटीग्रेशन ऑफ वेरियस इंफॉर्मेशन लेयर, सॉइल क्वालिटी स्कोर, क्लाइमेट क्वालिटी स्कोर, वेजिटेशन क्वालिटी स्कोर, लैंड यूज लैंड कवर स्कोर, इरोजन स्कोर, क्वालिटी स्कोर. उसके बाद 1 से 2 में स्टैंडर्डाइज करके इसको अभी आपने बढ़ा दिया. टेम्परेचर कंडीशन इंडेक्स TCI और वेजिटेशन कंडीशन इंडेक्स को कोरिलेट कर रहे हैं. व्हाट इज द सिचुएशन ऑफ TCI इन अगस्त, व्हाट इज द कंडीशन ऑफ VCI वेजिटेशन कंडीशन इन अगस्त. तो यू कैन कोरिलेट what is the value, and you can correlate the thermal condition. If the value is less than 40%, there is a thermal stress. If the value is more than 60%, there is a favorable condition. Likewise, the value is less than 15%, indicate drought from severe to exceptional intensity. Likewise, you can draw the quality map on the basis of integration of soil texture, soil depth, soil distribution of organic carbon. But a lot of field survey are involved. You see, this is the map of distribution of organic carbon, and you can correlate with the distribution of correlate with the SBI image, where the low carbon content is there. There is a positive relationship between brightness and the amount of carbon in that particular area. And these are the 83 sample areas from where you have collected the soil, and after the analysis of titration, you get the data of organic carbon, and you can correlate the presence of organic carbon with the SBI image. And likewise, you can generate the weighted map of organic carbon distribution, and after the standardization from 1 to 2 scale, after the integration of all these image, and you can find out the final image of the desertification hazard. But this is a very important and special kind of thing in the fragile ecosystem. How you will map the region? How you will map the region? Because pasture land is limited in Rajasthan. In every place you see that there is a livestock composition, and you can correlate with the distribution of rainfall. In western margin of the desert, you will find only goat, only sheep, and light weight animal you will find more as compared to eastern margin. But you have to prepare the composition of livestock for whole state, whole Rajasthan. If there is a camel is having 400 kg, if there is a buffalo cow having 400 kg, if there is a sheep 80 kg, goat 40 kg, how you will standardize? You have to calculate weight into livestock number. Means if you have standardized 200 kg standardized weight, where 400 kg camel and 80 kg sheep have been standardized, and cow is the basic unit, suppose only 200 kg or 300 kg. So you can calculate number of livestock with weight, and then you can find out the one adult cattle unit, and cow is the basic unit. So जानवर कोई भारी है, कोई हल्का है. पूरे राजस्थान में पश्चिमी भाग में भेड़ बकरी ये सब ज्यादा है. पूर्वी भाग में जहाँ थोड़ा वाटर अवेलेबल है, वहां पर कैमल भी है, भैंस भी है, गाय भी है. उसको भी आपको स्टैंडर्डाइज करना है. मान लीजिए आपने 250 किलोग्राम का एक यूनिट मानी, जिसमें ऊंट भी आ गया, बड़े जानवर भी आ गए, भारी वाले और हल्के भी आ गए. कुल लाइव स्टॉक से उसको वेट को मल्टीप्लाई करेंगे, और ये एज्यूम करेंगे कि कोई भी जानवर अपना जितना भी वेट है उसका 2% चारा उसको चाहिए. और राजस्थान में पास्चर लैंड लिमिटेड है, तो आपको फिकर सिर्फ ह्यूमन पॉपुलेशन की है. व्हाट इज द फूड रिक्वायरमेंट, बट व्हाट इज द फॉडर रिक्वायरमेंट, ये एक बहुत बड़ी बात है. घास निकलने से पहले ही अगर जानवर उसको चर जा रहे हैं, ग्रेस कर जा रहे हैं, तो आप स्टेबलाइजेशन की बात कैसे करेंगे? यानी ड्यून्स, बारिश हो रही है, हल्की बारिश हो रही है, घास निकल रही है, जमीन स्टेबलाइज हो रही है, और जानवरों का एक झुंड निकला फ्रीक्वेंट मैनर में, और स्टेबलाइज होने से पहले जमीन को एक्सपोज कर जा रहे हैं. तो देयर इज ए क्लियर एविडेंस ऑफ एंथ्रोपोजेनिक एक्टिविटीज लाइक ग्रेजिंग एंड मार्जिनलाइजेशन ऑफ एग्रीकल्चर ऑन एग्रीकल्चर एरिया. जो जमीन जहां कृषि होती है, जहां पर वो है, उसको मार्जिनलाइजेशन हो रहा है, ओवर कल्टिवेशन हो रहा है. और गंगानगर हनुमानगढ़ में बहुत सारा मार्च अप्रैल में पता चला सैंड उड़ के जा रही है, जो उसकी डिस्ट्रीब्यूटरीज हैं गंगा गांधी कैनाल की, उसमें सैंड एक्युमुलेट हो जा रही. बहुत सारे एस्पेक्ट पे आपको काम करना है. अब मीन एनुअल रेनफॉल, जियोमॉर्फोलॉजी में काम कर रहे हैं, भुवन पे चले जाइए, माइक्रो जो मॉर्फोजेनिक यूनिट्स हैं उनको आइडेंटिफाई करिए, एल्यूअल प्लेन कहाँ पर है, बरीड पेडिमेंट कहाँ पर है. फिर अपने हिसाब से सॉइल सैंपल किन किन एरियाज में गए. फिर आप गूगल सर्च इंजन में जाके देखते हैं कि कहाँ पर ड्यून स्टेबलाइज हो रहे हैं, और उनको ग्राउंड ट्रूथिंग कर रहे हैं, और कहाँ कहाँ पर वाइट पैचेस और एविडेंस ऑफ एंथ्रोपोजेनिक एक्टिविटीज हैं उनको आइडेंटिफाई करके, जो उसके जियोमॉर्फिक पैटर्न्स हैं उनको आइडेंटिफाई करते हैं। हेरिडिटी एनोमली इंडेक्स में जो आप IMD से डेटा प्राप्त किया है, वाटर सरप्लस और वाटर डेफिसिट एरियाज को आइडेंटिफाई करते हैं। VCI, ITCI और VHI का रिलेशन स्टैब्लिश करते हैं, ग्राउंड ट्रूथिंग करते हैं, क्योंकि सेटलमेंट एरियाज में देखेंगे जो आप क्लियरली दिखाई दे रहा है, हाई ड्यून्स, हाई इरोजन, नेकेड ड्यून्स, फ्यूड शेल्फ एरियाज। तो सेटलमेंट एरियाज में लाइफ स्टॉक के प्रेशर का, फॉडर रिक्वायरमेंट का, लाइफ स्टॉक के कंपोजिशन का मैप बनाएंगे, कहाँ पर कैमल ज्यादा है, कहाँ पर शीप ज्यादा है, कहाँ पर बकरियां ज्यादा हैं, भैंसे ज्यादा हैं, वो सारी चीजें आपको करनी पड़ेंगी। फाइनली जब इंटीग्रेट करेंगे 40-50 इंडिकेटर पे, तब आपको ये डिजिटली कोडेड मानचित्र मिलता है जो डिजर्टिफिकेशन को बताता है कि हाइपर एरिड पे इतना है, एरिड पे इतना है, ये। और उसके बाद जो है गूगल इमेज पे भी जाएंगे तो कुछ क्लियर एविडेंस मिलेंगे। इसी तरह से श्रुति जी का काम बड़ा मॉडलिंग पर है। मैक्सेंट पे अगर आप काम करते होंगे तो आपको पता है कि नेपाल पे अगर आप काम करेंगे, और आपने कहा कि हाउ सैटेलाइट ड्राइव डेटा यूजफुल फॉर प्रेडिक्शन ऑफ मॉडलिंग एंड डिस्ट्रीब्यूशन ऑफ प्लांट स्पीशीज विद रिस्पॉन्स टू क्लाइमेट चेंज। आप जानते हैं कि बहुत सारा डेटा सोर्सेस है, ग्लोबल बायोडाइवर्सिटी इंफॉर्मेशन, और उसके बाद वर्ल्ड क्लीन डेटा से क्लाइमेट का डेटा, और उस पर आप सॉफ्टवेयर पे जाएंगे अपनी रिक्वायरमेंट के अनुसार एनुअल मीन टेम्परेचर, जो कि पहले बड़ा मुश्किल हुआ करता था, अब मैक्सिमम टेम्परेचर ऑफ वार्मेस्ट मंथ, मिनिमम टेम्परेचर ऑफ कोल्डेस्ट मंथ, मीन टेम्परेचर ऑफ कोल्डेस्ट क्वार्टर, मीन टेम्परेचर ऑफ वार्मेस्ट क्वार्टर, मीन टेम्परेचर ऑफ ड्राइएस्ट क्वार्टर, जो भी आपकी आवश्यकता हो आपकी मेथोडोलॉजी के अनुसार सारा डेटा अवेलेबल है। सॉफ्टवेयर रन करिए और 2035 में, 50 में, 70 में बता दीजिए कि ये प्लांट स्पीशीज यहाँ पर सर्वाइव करेगी और यहाँ पर नहीं करेगी। तो मैं फॉरेस्ट फायर में नहीं बताऊंगा क्योंकि श्रुति और ये सूरज बहुत काम कर रहे हैं, तो ये अपना ऑलरेडी आपको किसी सेशन में बता देंगे। हमको 12:15 पे खत्म करना है, तो फॉरेस्ट फायर में भी हम इसको आप आगे स्केप कर रहे हैं। और एक बड़ी इंफॉर्मेशन आपको देना चाहता हूँ कि ये सब वेबसाइट हैं, जैसे बायोडाइवर्सिटी इंफॉर्मेशन सिस्टम, और इसके अलावा इंडिया बायो रिसोर्स इंफॉर्मेशन सिस्टम, इंडिया WRS, NIC GIS, पैसिफिक डिजास्टर सेंटर, और इसके अलावा ग्लोबल डिजास्टर अलर्ट एंड कोऑर्डिनेशन, ग्लोबल फ्लड मॉनिटरिंग सिस्टम, ग्लोबल फ्लड डिटेक्शन वर्जन सिस्टम, और ये नियर नेचुरल डिजास्टर हैजर्ड। ये सारी वेबसाइट को आप एक्सप्लोर करिए और बहुत सारा डेटा आपको इसमें मिलेगा। आप फॉरेस्ट फायर में फर्म्स का डेटा हम लोग यूज करते हैं जैसे, और ये अर्थक्वेक है, ग्लोबल सीस्मिक हैजर्ड मैप है, IMD की साइट पे जाइए, सीडेक डेटा फायर फ्लड और अर्थक्वेक से रिलेटेड होता है, भुवन का डेटा इस्तेमाल करिए, मोस्टैक और ग्लोबल। लेकिन जो लोग यहाँ पर स्टूडेंट हैं, हमारे जो साइंटिस्ट भाई हैं और जो वैज्ञानिक हैं, उनसे मैं नहीं कर रहा हूँ, सबसे पहले अपने आप को एक्सप्लोर करिए। जहां पर आप काम कर रहे हैं, सुरेश विहार यूनिवर्सिटी में पढ़ना है, इलाहाबाद में पढ़ना है, दिल्ली में पढ़ना है, इससे मतलब नहीं। पूरी दुनिया की वेबसाइट को आप एक्सप्लोर करिए कि आप एमटेक और MSc करके जाएंगे कहाँ, तो आपको लगेगा पूरी दुनिया में आपको लोग बुला रहे हैं, आप उसको सर्च नहीं कर रहे हैं। These are the well recognized institute. If you are interested in the work for making collaboration with these institute, you can write to professor on your specialization. जैसे कि आपके स्पेशलाइजेशन जो मैच करते हैं उनको आप लिखिए, हो सकता है कि आपको कल्चरल एक्सचेंज में या कोई बड़ा अवसर मिल जाए। तो सेंटर फॉर क्लाइमेट चेंज रिसर्च, इंडियन इंस्टीट्यूट ऑफ ट्रॉपिकल मेट्रोलॉजी पुणे में है, सेंटर फॉर क्लाइमेट एंड एनवायरमेंटल स्टडीज कोलकाता, देवचा सेंटर फॉर क्लाइमेट चेंज इंडियन इंस्टीट्यूट ऑफ, आप जानते हैं, बेंगलोर, जिंदाल सेंटर फॉर क्लाइमेट चेंज UK, कार्डिफ यूनिवर्सिटी इसके लिए जानी जाती है, सेंटर फॉर ओशनिक कोस्टल स्टडीज मद्रास, सेंटर फॉर एटमॉस्फेरिक एंड ओशियन स्टडीज इलाहाबाद, ये के बनर्जी के नाम से मशहूर है। हाँ, और ये जो आपका सेंटर फॉर एटमॉस्फेरिक एंड ओशियनिक साइंसेस इंडियन इंस्टीट्यूट ऑफ साइंस, और ये नेशनल सेंटर फॉर कोस्टल रिसर्च चेन्नई तमिलनाडु, इंस्टीट्यूट फॉर कोस्टल रिसर्च स्वीडन, फॉरेस्ट रिसर्च इंस्टीट्यूट इंडिया, और इसके अलावा वाडिया जानते ही हैं आप, ओंटारियो फॉरेस्ट रिसर्च इंस्टीट्यूट। बहुत सारे लोग यहाँ से गए हैं, और माउंटेन स्टडीज इंस्टीट्यूट MSI जैकब, और ये इसके अलावा सेंट्रल काजरी जोधपुर, इंडियन इंस्टीट्यूट ऑफ सोशल साइंस, वाटर रिसोर्स डेवलपमेंट एंड मैनेजमेंट, और यूनिवर्सिटी ऑफ मिसौरी कोलंबिया, University of Cambridge Conservation Research Institute, Center for Study of रीजनल डेवलपमेंट JNU, जोशी साहब बड़ा अच्छा काम कर रहे हैं वहाँ। इंटरनेशनल इंस्टीट्यूट ऑफ पॉपुलेशन स्टडीज, जो हमने शुरू में बताया कि अगर ये सब नहीं जानते तो सब बेकार है। IIPS देवनार मुंबई में, ग्रीन इंस्टीट्यूट जो लखनऊ का है, रीजनल सेंटर फॉर अर्बन इन्वायरमेंट स्टडीज ये, और उसके अलावा IRS देहरादून। थैंक यू। और ये सूरज जी और श्रुति जी, ये आपकी आने वाली बुक है जिसमें आपका एक पेपर है, और ये संभवतः 22 फरवरी को किताब आ जाएगी। और 12:15 हो गया है, घड़ी आप मिला लीजिए। और हमको भाई जो इम्पोर्टेंट लगा, 1 मिनट जरा सा मैं इसको करूँगा, और उसके बाद मैंने बहुत तेज प्रेजेंटेशन इसीलिए किया कि 12:15 में मैं ख़त्म नहीं कर सकता था। मैंने सिर्फ मैसेज दिया है और मैंने शुरू में कह दिया है कि मैं कोई एक्सपर्ट नहीं हूँ, मैं ज्योग्राफी का टीचर हूँ, लेकिन मैंने अपनी स्लाइड के माध्यम से ये बताने का प्रयास किया है। जैसे बचपन में एक मशीन होती थी, उसमें हम लोग कान में आँख में लगा देखते थे, और उसमें वो दिखाते थे कि दिल्ली का कुतुब मीनार देखो, बॉम्बे का ताजमहल होटल देखो, और वो सारी चीज़ें दिमाग में बसती थी। उसी तरह से हमारे जो स्टूडेंट्स हैं यहाँ पर, फैकल्टी के लिए नहीं, वो आप लोग हो सकता है कि बहुत बेहतर कर रहे हों, और मैं थोड़ा सा नर्वस भी हूँ, क्योंकि जब भी रिमोट सेंसिंग के लोग सामने बैठे हों और खुद का कोई बहुत ज़्यादा काम ना हो, तो बहुत ज़्यादा नानी से ननिहाल की बातें नहीं की जानी चाहिए। तो मैंने एक एक्सपोजर दिखाया है कि लैंड वाटर वेजिटेशन से कहीं ज़्यादा इंपॉर्टेंट है उसके थ्योरेटिकल एस्पेक्ट में जाना, और समाज को क्या चाहिए, और पेपर में लास्ट का जो पैराग्राफ होगा उसमें क्या चीज़ें होती हैं। इमेज रंग बिरंगी तो आएगी ही जब आप काम कर रहे हैं, और उसको आउटपुट निकालेंगे तो वो ऑथेंटिक है या नहीं है, उस पर बड़ा ध्यान देना है। और मैंने उन्हीं सारे एस्पेक्ट को लेके बहुत सारे थीम और बहुत सारे एरियाज को दिखाए कि शायद कोई सा थीम आपके दिमाग में बस जाए, उसको आप जिंदगी का एक मकसद बना लें, और उस पे ही आपका एक्सपर्टीज स्पेशलाइजेशन डेवलप हो जाए, और आने वाले 20 साल 30 साल 35 साल जितने भी आपके एकेडमिक ईयर्स हैं वो फर्टाइल बन जाएं, और उसमें आपका एक नाम पैदा हो जाए। तो थैंक यू वेरी मच फॉर गिविंग मी स्पेस टू शेयर माय some views related to the application of satellite data and remote sensing in the geographical research problems. Thank you.
Thank you very much, sir, for such an informative, enlightening, as well as wonderful lecture on the application of remote sensing and other technologies for climate change and disaster management, all the things. Sir, as we are running short of time, so I would like to take only 2-3 questions.
Okay.
So the first question is that it is from Priyanka. She wants to know how this depleting forest areas affects the economic growth of the country.
Okay. Actually, you will see the report of 2019, I think, and 2020-21 is also, I think, prepared and hope maybe released. You can download the data, because the agenda and objective of government to you will find there is a drastic change, as mentioned by Professor D.D. Sharma, because forest, if you will see, I have given the example of Gangetic Plain, where there is only 1.38 or 2.36%, and the average, I think, UP, there is only 6.86% forest cover in UP. And this is the best favorable, having the best favorable geographical condition for any area. There is a slogan of government, there is a effort of government people to for afforestation program. So risk of flood and risk of any major disaster, so it is very necessary to raise the plant in those areas are having difficult environment system. In Prayagraj, you will find in northern part of Prayagraj district is a very fertile plain, but in the southern part of Prayagraj, you will find that there are rocky and stony surfaces. But there it is possible, where there is a deforestation is going, where the practice of deforestation is going on. In the light, the role of scientists and role of environmentalists is to show the real scenario. Because if you are not going to do to cultivate plants, then you are going to invite any major disaster. You take example of flood or any drought, it is related with the forest cover.
Thank you very much, sir. Thanks a lot. Sir, as our next speaker is waiting for the lecture, so
थैंक
I
यू.
would
लेकिन
like to
मुझे
stop
माफ
here.
कीजिएगा कि
And if
मैं बहुत ही
anyone of the student is having some question, then they can directly contact to you, sir.
हाँ थैंक यू. लेकिन मुझे माफ कीजिएगा कि क्योंकि दीदी शर्मा जी ने थोड़ा 15 मिनट ज्यादा ले लिया था, तो वही 15 मिनट मैंने एडजस्ट किया.
No,
यहाँ
sir,
पर 3 मिनट ज्यादा हुए हैं.
It's fine, sir.
और
It's fine,
और
sir.
1 घंटे में इतना कवरेज इतनी तेज मैं बोल रहा था कि अगर नहीं बोलता तो 12-15 पे खत्म ही नहीं कर पाता. थैंक यू
Yes,
वेरी
sir.
मच.
आपने सर बहुत टाइमली मैनर में और टाइम बाउंड में सर आपने कंप्लीट किया और वंडरफुल लेक्चर था सर, काफी इंफॉर्मेटिव था. तो सर इन नियर फ्यूचर वी विल आल्सो हैव सम लेक्चर्स, so we have more interaction with the students.
थैंक यू. थैंक यू.
Thank you very much, sir. So now I would like to call upon Ms. Priyanka Roy for inviting our next speaker.
Thank you, sir.
Priyanka, please proceed.
थैंक यू. थैंक यू.
Thank you, sir. Now, moving forward with our next guest speaker, Dr. Chandra Prakash Singh. He is scientist engineer, SF in Biological and Planetary Science and Application Group of SAC. He did MSc Environmental Science and Ecology from Purvanchal University, MTech Remote Sensing from BIT Mishra, and doctorate in Environmental Science from HNGU Patna. He has played key role in various prestigious projects related to satellite remote sensing application in field of environment, ecology and forestry. Under his leadership, he has established a first of its kind Himalayan Alpine Dynamic Research Initiative, HIMADRI, for long-term ecological monitoring in Indian Himalayas. His field of interest is also including algorithm development of active forest fire detection, bioecology, ecosystem modeling, phenology, lichenology, climate change impact studies, wildlife habitat, inch modeling, leader remote sensing, and so on and so forth. He has represented India in various international fora. He was part of recent 39th Indian scientific expedition to Antarctica conducted in the year 1990 to 2020. He has, to his credit, more than 100 publications, out of which 40 are peer-reviewed journals and book chapters. He is active member of many professional scientific bodies, including Indian Science Congress Association, Indian Society of Geomatics, Indian Society of Remote Sensing, Indian National Cartography Association, Indian Lichenology Society, Indian Meteorological Society, Astronomical Society of India, and Indian Society System of Science and Engineering, and many more. On this note, I would like to invite Dr. Chandra Prakash Singh to take forward today's event. Sir, you're most welcome.
Thank you so much. Am I audible?
Yes, sir. Clear.
Okay, thank you. Thanks for my introduction, and thanks, Shruti, for inviting me for this particular series of lectures. So without wasting time, I think I have to finish it by 1 o'clock.
Sir, 1 hour. 1 hour.
1 hour I have. Okay, fine. Thank you. Great. Still, I don't want to come in between your lunches, so I'll try to finish it as early as possible, right? So what I'm supposed to talk about today in this particular lecture is remote sensing in forestry and wildlife studies. So I'll try to combine both the studies in a certain manner that taking some of the examples what we have done at Space Application Center. But I'll be trying to be generic as much as possible. All right, so let us talk about India. First of all, we are very rich in natural ecosystems, and recently you must have seen that Indian status of forest resources are published by FSI, Forest Survey of India, according to which now we have around 21.71% of the geographic area of India as a forest cover. All right, and which is a slight increase in which has been shown, and then tree outside forest is also computed. So if we put together, we have around 24.62% area as tree clad and forest area, which is a good amount of area. I would like to say that for any country, if you are having around 30% of the area, that is supposed to be very healthy. So we are having almost like near to that number. Some of the states are very rich in terms of forests, like northeastern states, Western Ghats, and central India. So But when we talk about forests, then the management is becomes very problematic if you want to do on the ground. Okay, so some of the resources which can be monitored very well in difficult terrains, like mountainous areas, where going by foot and traversing the entire area and enumerating them becomes very difficult and time consuming. So it's a good option is there, remote, in the form of remote sensing, so which we try to leverage. And there are a lot of advancements which are coming up these days in terms of monitoring capabilities. So there are a good number of parameters which can be monitored from remote sensing. We will try to discuss in this presentation. All right, so coming to while being introduced before this lecture, we have actually initiated Himalayan Alpine Dynamics Research Initiative in Indian Himalaya. Why? Because IPCC once mentioned in around 2014 or so that Indian Himalaya is a white spot in terms of data. There is hardly any data being generated on the ground, and remote sensing is useful only when it is validated, on the ground with some measurements. So there is hardly any validation which was available in terms of various phenomena which being monitored, which are climate quality kind of data is missing, so that IPCC or some such agency can talk about whether there is any impact on mountains in terms of climate change. So we started making this plan, and now we have successfully having stations on the ground which are monitoring various parameters, which helps us in validating remote sensing based parameter retrievals. All right, so what are those parameters which we can derive? We'll talk about it. But before that, why mountains are important when we talk about climate change? Because these alpine ecosystems in India is not what exactly is there in Alps or in other countries which are like European countries. There, the coldness in these environments is not by virtue of the height, the mostly they are because by virtue of their latitude. Latitudinally they are up, so that's why they are colder. Okay, and we being tropical countries, we are having high warmings. So when we go to the mountains like Himalayas, and we try to go up in the mountains, as you know that there is a lapse rate fundamental which prevails, and as you go up in the altitude, the temperature will fall down, and we go up to 3000 meter in Himalaya, that becomes equivalent to what we have latitudinally high countries. So we start having alpine ecosystems over there, and these alpine ecosystems are temperature limited, and that's why they are very sensitive to any change in temperature, and that's why climate change impact becomes very important to study there. Okay, so we get faster signals over these areas which are limited by temperature. So any change in the isotherm, where the life form is defined, will give you some indicator that there are impacts of climate change which are happening. All right, so what are those indicators? The indicators could be densification in the forest, where the temperature is the limiting factor for the growth of the plants, and any growth which is being hampered by the temperature is getting released due to warming will also be an indicator. Like if I say the tree height start getting reduced if you go up, okay, because they try to attain the crumholesness or shortness in their height to save themselves from the coldness. Okay, and this property can be enumerated if you are having LiDAR kind of data available, which is nowadays available from the remote sensing platforms, like International Space Station is having LiDAR sensors. So if you try to study the tree height variations in these mountains, you will find, and you will get to know that there are definitely there is a rate of change of tree height which is happening. So which we have also recently tried to enumerate using LiDAR, space-based LiDAR sensors, and we are going to publish it very soon. So in short, what we have understood from remote sensing in these areas, which is related to forest and climate change segment, that we found that there is a mean shift, okay, mean shift in 4 decades of the order of 381 meter. And this was a big news, because this kind of shifts have not been earlier indicated through modeling efforts or through other publications. So they tried to investigate it. We tried to validate from the various other you can say parameters, like on the ground, whether it is validated. So we have to go back in past. Remote sensing allows you to go back in past up to 1970s, 72 kind of data you can have very well from Landsat and try to see what kind of changes are there. But if you have to go more in past and try to have a baseline record, then you have to take care of other techniques, like lichenology is one such technique, where you need to study lichens, their life forms, their how their growing patterns are there. And then by studying their and knowing the rate of change of their growth, you can very well establish that this particular substrate was opened up in which time frame. And from that, you get a clue of changes in the alpine ecosystem. Then there is a dendrochronology, that is paleobotany kind of study can be done for going back in past. Even herbarium records can be used for reconstruction in these areas. So there are various methods which we are trying to understand. Even at physiological level, we are running some of the experiments which are known as open top chamber experiments, where we are ingesting carbon dioxide to the plants in situ, so that we can just vary one parameter like carbon dioxide and see the impact of enrichment of carbon dioxide, which is going to be there in various RCP scenarios. Okay, and there are certain modeling efforts which can be done, like simulations. Simulations are the using geospatial technique, which are also known as niche modeling, where various machine learning algorithms can be utilized for predicting what kind of future scenarios can be there. So this is just a glimpse of where all we have the stations. We have one station in Jammu and Kashmir, then one station in Himachal, and we have two in Uttarakhand, because one station is dedicated as a master site where we do extra experiments, as I was just mentioning about OTC experiments, even various invasive species like polygonums, which are destroying the ecosystem there. So we are trying to study those things also. So there are various field-based studies apart from that, which can be used for validating various remote sensing based products that we generate. And then one we have in Sikkim and Arunachal, we have recently added one more station. And then since 2013, we are studying, and we have large amount of data, not only on the biodiversity at the quadrate level, at various summit level, that we are also having soil temperature logger data, which is very important, because the growth of these mountain ecosystems, plants, are limited by not by the maximum temperature or mean temperature, by the minimum temperature of the soil, because that defines their growth, physiological growth. So that also we are recording, and now we are going to give the entire world the lot of data which is being generated through these stations, so that the Himalayan mountain ecosystem doesn't remain hot, white spot in this arena. So these are the our Alpine Summits, which they look like. We go to the top of the summit, and then from there we start measuring down below. We lay the contours of 5 meter, then 10 meter, and then various quadrates, which is based on the international protocol from Gloria. And then we put our quadrates of 3 by 3 meter and start enumerating the biodiversity. Now you will think that this is all ground-based studies, but these ground-based studies gives important inputs to us when we claim something from the remote sensing. Like here we have found that there is a thermophilization which is happening. So the plants which were known to grow in the lower summits are now growing on the higher summits. So the thermophilic species are occupying the areas where cryophilic species used to be there. So this is an important indicator that yes, the changes that we are reporting, like tree line shift and densification and phenological changes, are true. On the ground also it is being recorded. At the same time, spectral biodiversity can also be measured. So there is a fundamental principle that the biodiversity is nothing but entropy, which is the equation. If those of you who are from the botany background will understand that what is Shannon-Wiener index, This is a measure of biodiversity. On the ground, you compute basically entropy. So this entropy can be computed if you define a kernel and you add various spectral bands. The similar thing you can compute using the remote sensing data. So there are various indices which have been developed, and they are known and they are established, published, and which can also be utilized for computing the spectral biodiversity. Though there cannot be one-to-one match from the ground-based biodiversity, but spectral biodiversity does have some scientific basis, and it can be computed, and it can be in future it can be compared from the past data to understand that what kind of changes is happening in the spectral biodiversity as well. Now coming to the modeling efforts, what we have done, we have tried to understand from the past interglacial period to current time to future climatic scenarios. Like here I'm giving you example of RCP 8.5, and we have tried to see that in future a particular ketone species like Betula utilis, which is also known as Bhojpatra, which primarily thrives above 3000 meter elevation in mountains of Indian Himalaya, how they are going to change their habitat, okay, in response to the climate change and warming. So there are a lot of bioclimatic indices which are generated using IPCC based future projections, which can be utilized for training our current species locations, which we call it presence record. So the presence records can be calibrated with the today's available bioclimatic indices, and future climatic indices can be projected based on future climatic projections. You can project that where this particular species will go in future. Though there are certain things which cannot be modeled, like you can say dispersal of a tree, because for any tree to go and germinate at a particular place, there has to be a dispersal mechanism. Okay, either it is through the birds or through various other pollination mechanisms. So whether those mechanisms are prevailing in those areas or not is not being considered right now in these kind of models, but it definitely tells you that it holds the ground. Conducive conditions are there for this particular species to thrive over there, if there is no barrier in between for their migration. Okay, so this was also published, and we have shown that there is a tremendous scope of change in the habitat, and mostly we have found that northeastern Indian portion and northeastern Himalaya will be affected more and more than western Himalaya. Coming to the lichenology, I just shared with you some of the thoughts in initial slides, but this is what lichen is. Basically, it's a species like algae and fungus put together becomes a lichen, and this thallus, some of the lichen species grow circularly, and their rate of growth is known. Like in case of Rhizocarpon geographicum, it is around 0.2 millimeter per year. Okay, so if it grows so slow, and if you can measure them when you go up in the mountains, let's say from 2000 meter elevation to 3500 or 4000 meter, I keep on taking a transect and keep on measuring a particular species and their growth records, I'll come to know that these substrate were free from ice in what time frame, because it will grow only on the undisturbed surfaces. And this gives us a clue that what could be the rate of change of the Himalayan ecosystem. And we also do the lichen niche modeling, which is also giving us good, you can say, areas where we can do more lichen sampling and more lichens can be found. And using hyperspectral data also, lichen mapping is possible. That is what we have demonstrated using recently conducted survey using RS and GIS, which is the world's best hyperspectral sensor, which was flown in India also at certain places. So we had the opportunity of taking data sets at Himachal Pradesh, and there we have tried to use match filtering technique. So if you have on the ground lichens are there, you can have their spectra using handheld spectroradiometers, and matching the same spectra to the airborne RS and GIS kind of data, which is very high in terms of spectral bands. More than 400 bands are there. So you can try to match this spectra to the space-based hyperspectral sensors or airborne sensors, and you can match it and try to find out those pixels which are very close to what we have recorded using handheld spectroradiometers, and this will give you a classification. So this is an example of such techniques which can be utilized. Generally, these techniques are utilized by geologists for mapping minerals. This same technique we have utilized for lichen mapping. This is just one example of how remote sensing is useful in assessing the damages done by various natural forces, whether it is forest fire or it is cyclone, how the damages are done. And this is one exercise that we did recently. Taute cyclone hit Gir forest, and then we try to do the assessment that how many trees would have fallen. So we used optical plus SAR data, both combined together, and tried to assess it. So uniqueness of this particular study is a combination or hybridization of two techniques. One technique try to see the biophysical parameter of the vegetation, and second technique try to see structural disturbances which has happened. So the pre and post cyclone data were taken, and we tried to understand that what kind of changes would have happened, and areas which are affected moderately, less, or highly were categorized, and we have given assessment to the forest department as well for the particular thing. And we tried to do vicarious validation as well. What we did, we flown some drone over there with the help of forest department, and we got the data from them, and we computed per hectare how much trees are there actually on the ground. So the number of trees, the mean number of trees were assessed. So that was around 75 trees per hectare. And so if you multiply the area with moderately to highly affected area, we assessed around 32 lakhs tree would have been affected. So these are basically windswept trees. So some of the trees may also later on may recover because they are not uprooted completely. They are just slanted, they are just lying on the surface, but they may later on get revived. So these are windswept. Total number of trees which are windswept were computed, and we reported it. Coming to the second kind of disturbance to the forest ecosystem, which is forest fire. So large number of forest fire activities happen in India, and mostly 99% of them are actually anthropogenic in nature. Maybe by negligence, or maybe by some kind of knowingly form of a disaster in many forests. And these days you must have heard about Uttarakhand fire, which has happened a couple of years back, like 2016 also there was a fire, then 2018 a large number of fire was there, and it was we lost a good amount of forest base. But luckily in India, the forest fires are starting from the surface when there is a large amount of litter falls are there, and then during summer season when fuel load is high, when the leaves are shed in deciduous forest, and then the fuel moisture content is also very low. So that time it becomes very condition becomes very conducive for any fire mishaps to happen. Anyway, how remote sensing can help in detecting forest fire? We'll just try to see what is the physical basis through which remote sensing can help it. Not that all bands are good for detecting the active forest fires. Though if once the forest fire has happened and you have large area as a char which is available, and that can be assessed. Some kind of change detection analysis you can do, and burnt scar mapping can be done, or the area affected by fire can be done using simple optical remote sensing kind of data, which is available from IRS kind of series of satellites, or Landsat or Sentinel optical data. But if you want to detect active forest fire, then you need certain very specialized bands, which are neither directly into thermal domain or not in optical. They are known as middle infrared. Middle infrared bands are known for detecting forest fire very effectively because of their physical properties which amplify the signals coming from the forest fire. So you can see from this particular curve, the Planck function curve, that I'm giving an example of insect 3D, which is having this channel. And you can see that as the temperature are increasing, okay, from the fire. So each curve is having the number for the temperature of the surface. Okay, so 250K to, you can see 500K I'm showing. The maxima of the peak of these curves are shifting towards the shorter wavelength. Okay, so I'm showing you the wave bands here from, let's say, 1 micrometer to 15 micrometer. You can see that the peak of these curves are shifting towards shorter wavelength. And 3.9 micrometer or 4 micrometer kind of channel, which is my MIR channel, is very ideal for detecting these peaks, which are emanated from the radiances which are emanated from the forest fires. And forest fire, bush fire starts from 500 Kelvin, and forest fire can go up to 800 Kelvin to 1000 to 1200 kind of temperature can be recorded. But designing such a sensor which can record such a large amount of temperature radiances is very difficult. So we go for engineering challenges, or found with some kind of you can say approximation. So what we do generally, we design sensors which can detect temperature which are above from the Earth's surface temperature to certain magnitude, which is good enough for detecting such anomalies. So you must be aware that Earth's surface temperature, the background temperature, around generally 300 Kelvin. So anything which is 300 and above can be useful for detecting such anomalies. So we, in this particular channel, 340 Kelvin has been designed as a condition for saturation. But in my opinion, this is not sufficient. We should have at least 450 or 460, 70 kind of Kelvin to avoid other sources of such saturations, which include sun glinting effect as well. So sun may give a glinting effect on the clouds and other surfaces like forest itself at this kind of spatial resolution, which is 4 kilometer. So it becomes surface for as a mirror, and it gives you glinting effect on the sensor, and sensor becomes saturated. So to avoid such things, we should have high saturation, any delta T kind of scenarios to detect the forest fire. So these are example of a generic algorithm which generally is used for detecting forest fire. This is known as a contextual algorithm, where you take MIR band and thermal bands, and initial thresholds are defined to weed out the pixels which are not potential forest fire pixels. So this is based on rejection principle, where you keep on rejecting the pixels which are not useful for the forest fire detection. So initial thresholds are applied, and these thresholds can be made dynamic because daytime and nighttime temperatures would be different for the surface of the earth. So you can define little lower temperature thresholds for the nighttime data, and for daytime data you can have little higher. And then you try to see the difference between the thermal channel and MIR channel. If it is beyond certain thresholds, then you qualify them as a fire pixel. And then you start doing statistical based, which is known as contextual test, whether it is 2 sigma above the threshold, or 3 sigma. So that fine tuning has to be done at various level to understand that whether 2 sigma, or it is basically tightening or algorithm for avoiding the false fire alarms. So after doing all this, you get to see some of the pixels which are qualified as forest fire, and you can then further validate it and then do the analysis of the phenomena itself. So here are some of the case studies I'm presenting to you. We're using INSET 3D, which is 4 kilometer by 4 kilometer pixel resolutions. We have tried to understand whether it is useful to understand and study forest fire events. And we have found that yes, for large fire events, which are in terms of more than, you can say, 0.2 hectare area is under fire, INSET 3D is very useful. But when we compare with MODIS being 1 kilometer and having high better any delta T of their sensors, they can even have 0.01 hectare kind of land under fire. can also get detected. So comparing directly MODIS versus INSET 3D becomes a little issue, because we should compare the comparables only. Though the phenomena is same, their detectability are not same. But INSET 3D, being geostationary orbit satellite, it gives you an advantage of monitoring every 30 minutes, the same event. So the progression of fire can be monitored very well if the fire is little larger. So we have tried to see for Uttarakhand fire that it works very well. Now coming to, once you have these kind of fire products available from whether ATSR, or you can say you are also having fire events. If you want to go back in time, you have fire events available from NOAA VHR also, 1960 onward, okay? And then you have from Landsat also some products are there. But active forest fire products are available from, you can say NOAA VHR, then AATSR, and now recently you have the best data which is available from SOMI NPP. So there is a satellite known as SOMI NPP sensor, which gives you very good data at 375 meter. So what we try to see that whether these data sets are, if at all, they are useful for understanding various other forest related parameters. So I tried to understand and try to open up a branch of a study which is known as pyroecology. And through this, we are trying to understand whether the forest fire events which are happening is having something to do with the biodiversity or something to do with the heterogeneity of the landscape or not. And this is the result, and very interesting result. You can see whether you are having the leftmost graph is showing INSET 3D based fire histogram over a period of time from 2016 to 17. Then from MODIS 2002 to 2018, very long time data at 1 by 1 kilometer, and then from SOMI NPP 2012 onward, and then this is at a very high resolution. So whether you have very high resolution for a long time, for a short time, you are going to get this kind of curve. And this curve is very interesting, showing you habitat heterogeneity versus fire counts. Okay, so if you see a particular number of habitat heterogeneity is causing the fire to decline, and that is coming around 2.2. So that makes me think that if we have habitat heterogeneity of a high level, around 2.2, then fire is supposed to be less. Why? Because monocultures are going to give you same kind of phenology, same kind of calorific value of the wood and many other things, and that once they are under fire, all will become all will be having the same conditions, and no fire break will be available. So having different kind of tree plant. So whenever forest departments are going for plantation, we should suggest them that they should maintain this kind of heterogeneity in the forest. It should not happen that only monoculture plantations are or afforestation programs should not be having only one species. So this is an important input from this kind of studies. Then there is another thing which can be done for forest fire risk, and that is also from the remote sensing. You can understand this. Forest fire risk can be mapped using dynamic and static parameters. You must be aware that a particular topography which receives large amount of insolation from sun becomes warm, and if there are fuels available, it can have fire. So satellite-based DEMs are known to you. Using various techniques, whether it is interferometry or photogrammetry, large amount of data has been made available free to people to use for such scientific applications. So SRTM DM is one such DM at 30 meter you can utilize. Then Astro DM is also available, and there are many commercial products are also available at high resolution. Even 5 meter kind of data is also available. So depending on our applications, we can utilize such digital elevation models and deduce slope, aspect, and elevation kind of information from them to understand what is the area which is going to be warmer than the other area. And then there are certain dynamic things, which are going to change from one time to other time is the meteorology. And meteorology includes rain, temperature, relative humidity, and even solar insolation as well. And then you should have socioeconomic data, because as I said, 99% time it is anthropogenic in nature. You should also understand from As a GIS layer, we can include socioeconomic data sets like roads, settlements, proximity from these elements. As a propagation potential and ignition potential, both are important in this segment. And even one more dynamic feature could be phenology. So you should know that when the forests are getting loaded with this fresh litter and they're very dry, and they can induce fire. And then fire history is also important to understand, in like a particular region how frequently receives fire. So fire history from satellite products can also be generated and can be used as one layer. And fuel moisture content, which is an area of research, open area of research. So how to actually deduce fuel moisture content? So I believe SAR kind of data are very important because it can penetrate to some of the bands like L band, P band can penetrate up to the base layer of the forest, and it can give you information about the fuel moisture content availability. But it requires a large amount of research on the ground, also using some of the instruments. You need to first compute what is the fuel moisture content, and then try to calibrate your backscatter, and then come out with a model which can generate a fuel moisture content data. And that should be for the bigger area, not as study area site based kind of equations. So universal equation should be brought out, and such products should be available. Then only we can make it a very dynamic forest fire risk assessment model, and this can help us. Though people are trying, and even FSI is through various other, not having all the parameters which I have listed here, some kind of static kind of maps are being generated. But if all these elements are considered, we can have a better model. This is one example case study I'm just trying to share with you, using geospatial technique, we can better inform our forest managers for designing their watchtower, and watchtower optimization and management can be done through that. And even there are certain tools which can be used for better location of real-time forest fire management, or you can say dowsing the forest fire, when to send the parties, which area to send the party can also be done. So in the first view graph, you are saying the tower visibility analysis has been done using digital elevation model. So existing towers are plotted with their heights, and then DM is used for doing the view shed analysis, and you can see there are large amount of area which is not visible from any of the tower, and there are certain areas which are visible from more than 5 towers. Okay, so optimization of the watchtower can be done in the forest area. And then second application can be made, how these forest fires are reported in the particular wildlife sanctuary or any such protected area. They have watchtowers, and guard will be there, and he will inform to the control room that I can see a fire in my north direction, and approximately it looks like 1 kilometer from my tower. So this is how they are going to give you the information, and that is not going to solve you the problem. Okay, so the second tower guard is saying that he can see from the northeast direction, it is the fire can be seen or smoke can be seen. So ultimately, to decide that exactly how far it is from the particular towers, if at least 3 tower people are giving you information, correct information, you can do the kind of a triangulation, and through this kind of software which we have designed and given them, and they can have a better location of the fire which is being reported by the forest guards. Now, I mentioned a couple of times phenology. Phenology is very important element of forests as far as the deciduous forests are concerned. They shed their leaves in a particular time, and then again the greening start happening. And remote sensing, since we are now having time series kind of data sets available, there are many satellites are being launched. If you put together all of them, or some of the satellites are capable of giving you daily informations. Like Modis is giving you daily pictures. So if you can use this data effectively, you can generate phenology matrices of the forest ecosystem. And these are giving you very nice clues. Apart from the instantaneous observations, it is also giving you long-term observation. If you're doing, if it is going to give you various clues of changes which are happening by virtue of the weather parameters which are changing, and that can give you important handle in predicting the future scenarios, that what is going to happen, whether my phenology curve, the total length of the growing season, whether it is going to shrink or expand, or it is going to shift from what is known in the time domain. So all this you can understand very well, and that will give you important feedback to various forums, whether your carbon sequestration is going to be high or low, or it is going to be changed from one time frame to other time frame. So this becomes very important in terms of productivity measurements or even carbon sequestration parameters. So these are some of the experiments that we have done on the ground also, like a particular tree sections have been observed for a long time, and we have tried to understand from the satellite data. But now we are going to do it very systematically. In the entire country, we are going to have a phenology network very soon. Already 3 stations are working, and many more will be working very soon. And we will be having a first of its kind forest phenology network of India. And this will be precisely having phenomet tower actually. So not only the phenology camera, which will be taking picture every day, it will also have forest, you can say, specific meteorological sensors, which will also have soil temperature at root zone depth and surface, and then soil moisture and solar insolation at the canopy level, and many other parameters which we will be observing, so that we can develop a phenomet model for the country for various 16 forest types which we have as per champion set classification. And we can have equations for all the forest types of all the regions, and we can we'll be doing the future kind of modeling, that in future what is going to happen with the phenology. And we are already having a lot of interesting stories coming out from these phenomet towers. One specifically from Tungnath is giving us observations, and we have recently found that in one particular year, the flowering in a particular important plant, which is known as rhododendron, we missed the flowering. And we missed the flowering because of heavy snowfall. And because of this heavy snowfall, the temperature which is required for vernalization and you can say the flower bud burst, it could not happen. Heavy snowfall raised the temperature of the soil, and because of the blanket effect it can give to the soil, and it caused that particular phenomena. So it is having large implication, because this flowering is absent for a particular year. It will not only hamper the local economy, because local people take these flowers for making various squash and many other things, but also there are a lot of bird species which comes to take the nectar out of these flowers. So all those problems are going to be there. So phenology becomes very important, though from remote sensing we cannot talk about flowering phenology, but only foliar phenology we can talk about. So these kind of products will be generated in future, the start of the season, how it will look like. So each pixel will be having a Julian date, that at this pixel, a particular date was there when the start of the season, like leaf initiation, or you can say in terms of NDVI, only 0.2 NDVI was there, and then 0.8 NDVI reached at this particular time. So each pixel will be having a Julian date, and you can compare from one year to other year that how it is shifting. And yeah, this is an example of how light use efficiency model can be utilized for computing the gross primary productivity of the forest area, where we can utilize phenology scalar, water scalar, temperature scalar, and we can generate the gross primary productivity. And we have computed it to be 2.4 gram carbon per meter square per day for our area. And this is one interesting application I just wanted to show you on the net primary productivity. The phenology that I was showing you, if you follow the curve, it start, let's say, in a particular month, like after rainfall, the first shower starts, the leaf initiation takes place in the deciduous forest. And during winter time, it sheds all its leaves. So in between, what is happening? In between, there are a lot of photosynthesis which is happening. So this photosynthesis is nothing but accumulation of carbon, which is done by the forest, and it can be computed for that particular year how much carbon has been fixed, and net primary product can be computed. So there's a modeling effort which can be done using large integral of this growing season can be utilized for capturing the photosynthetic activity which has been done by this forest. However, there is a forest biomass mapping effort also being done using microwave data. This is an example of C-band, our own ISRO's RISAT-1 C-band data, which was used for mapping the above ground biomass. Now, you may be thinking that whether C-band is good enough for doing above ground biomass because it cannot penetrate from the very dense canopy. So yes, you're right. C-band can be utilized for the lower biomass regions. So that's why I'm showing you the example of lower biomass region of Gujarat. But if you go to northeastern area, you need to have L-band or P-band kind of data to have better assessment. Though it is also going to saturate beyond a particular biomass level, but still something is better. So L and P-band can be utilized. So there's in international arena, there are a lot of satellites are being built. Even a biomass satellite is being built for such kind of assessment. So in future, we'll be having such products available from the satellite. Coming to mangrove, same as alpine ecosystem, mangroves are also known to be very sensitive for changes, climatic changes or changes in the parameters on which narrow parameters at which they thrive. So you must be aware the mangroves are generally thriving at the areas where fresh water and saline water mixed up, and then they grow very nicely over there. So in these areas, estuaries, there are a lot of changes are expected when we talk about climate change. People talk about like Antarctica, when it is going to melt, a lot of ice shelf area is going to be melted. So inflow of fresh water will be more in ocean, and salinity will be lesser. So mangrove will be affected. So all these studies are being done, and people try to understand what kind of impacts are being observed in the mangroves. So some effort has being done using satellite data also to understand the mangrove health, their stress detection. So on the ground, there are a lot of parameters which are being studied, and using satellite data also, like mainly hyperspectral data will be required for such kind of studies. Now coming to the next segment, I think I have completed almost half of my presentation, and now I'll be going fast to have more introduction from you. But I'll just try to give you some of the examples of wildlife habitat kind of modeling that we have done using satellite data. And what are the various elements? I'll just try to give you some of the glimpses. So when we talk about wildlife habitat, they are very integral part of any forest ecosystems, and there are various components which are there which can be utilized for understanding the wildlife habitat, whether it is site selection or reintroduction of a particular wildlife species, watershed kind of analysis, resource inventories, niche selections. Network analyses are very important to understand how a particular patch of forest should be connected to another patch to have mixing of the populations. Spatial measurements, corridor analysis, GPS tracking of animals, hotspot modeling, where all the particular events are happening more and more. So hotspot modeling is very important. Resource exploration studies can be done for particular ketone species. Geofencing is very important. I'll just give you for example of geofencing here. This is the basically application of the GPS technology. So let's say a particular animal, if it is harming a villager regularly, you can do geofencing of that area, and somehow that particular animal can be collared with GPS, and once it reaches near to that particular buffer area of that particular village, there will be an alarm, a siren, which will be blowing up, and then people will know that this particular harmful animal is very near to our buffer area. So they will be alerted. So these kind of applications can be done for wildlife related studies. So I'll give you some of the examples, and before that, let us clear some of the fundamentals. When we talk about the wildlife management or forest management, we should be very aware that at what scale we are trying to understand this particular phenomena, whether it is at the biosphere level, biome level, landscape level, ecosystem level, community level, population level, or species level. So this becomes very important. In my initial slides, when I was talking about alpine ecosystem, you must have seen that we are going up to the species level to the biosphere level. When we are doing modeling of the niche and trying to understand a particular species, how it is going to change in future, its habitat, so that is at the biosphere or biome level. But when we are measuring the species at the ground, that becomes at the species level. And then we are trying to pull entire data and understand the population and community level. And then when we are modeling at the ecosystem level, the entire, you can say the ecosystem of alpine, like if I talk about a belt of 3,000 to 4,000 meter, that becomes an ecosystem kind of modeling. So scale is very important, and accordingly your data should be available. And then remote sensing also helps you in getting the data at those kind of levels. Okay, so you can have cartoset level for very high resolution kind of data. Even you can count trees. True, you can have biosphere level kind of data. And also in time domain, it can be modeled, as I said, from daily kind of observations to you can say every monthly kind of observations. So landscape becomes very important when we talk about wildlife conservation or management. You can see in this example, there is a natural landscape which is very intact, and then we start seeing fragmentation because of human activities, whether it is for the expansion of agriculture or expansion of urban areas. Then we start having our road, our railway lines. Then we start having fragmentation of the landscape, and many populations get alienated from one to other, and it has large implications. And now, if we want to connect them again, we need to design corridors. This is an example of a study of habitat mapping of Kanha National Park, where a very unique set of problem arose, and Forest Department approached us that Kanha National Park being a protected area, wildlife area, where tiger reserve basically is there, not even a leaf can be touched by the Forest Department. Nothing can be cut. So it is allowed to grow as per natural conditions. So there are a lot of woody tree species which came into the grasslands, which are basically cleared initially for deer. So large deer population or Barasingha population is also there in Kanha National Park, which is the primary food for the tigers. But as in time passed away, these grasslands were encroached or ingressed by the woody species. So the total area of these grasslands were started decreasing. Now they wanted to cut the trees, but they were not allowed. So ultimately, it was hampering the carrying capacity of the entire park, because the number of deers are increasing day by day, and they should have more area to graze on. And on top of it, the woody species are encroaching the area. So they wanted to have an assessment, scientific assessment, to prove this concept, whether there is an ingression which has happened from past to not. So we used even corona data. If some of you may not have heard, I'll just try to inform you that corona is the spy satellite of USA, which was also released some time ago. And then this data can also be used for some of the assessments, if you want to go back in 60s time frame. Very high resolution data sets. So what we did, we informed them for these kind of encroachments and how much encroachment has happened for which species, and then some management activities was taken up. And this is an example of habitat modeling for Barasingha in Madhya Pradesh. If you are not aware, I just like to inform you that hard ground Barasingha, which is known as Rucervus duocelli branderi, is a only species which thrives on earth in Kanha National Park. Some time back, when we started this study, it was only available in Kanha National Park. Forest department wanted us to understand from scientific perspective, like which are the areas which are bioclimatically suitable for reintroduction of this particular animal to other areas, so that if anything happens to this particular population, at least we save this germplasm, or you can say the species, in some other place as well. Otherwise we'll see that one more species is wiped out from the earth. And you may be aware that, every day we are losing some or other species. So what we did, we used models like machine learning models, support vector machine, environmental distance, climate space model, genetic algorithm for rule set production. And we used the populations which were existing from the past history, when our country got freedom. That time also we had a good amount of population in other places as well. But over the period of time, due to urbanization and agriculture practices being improved, we are now losing these species. So what was the scenario earlier in past, like in 1960 and 1972 time frame? This kind of records were available from one author, Scheller, 1967, and we digitized these records, and we tried to make a niche model out of this. So this is the model, this is the area that you are showing in the hatch pattern is from the Scheller. He has given a map of distribution of Barasingha in India and around. And then we use these points and try to model it using our support vector machine and CSM. And we saw that similar areas are being highlighted by the geospatial model as well. And this gives us the confidence, and then we further corrected it with the prevailing today's current land use, and we gave them a proper map where high suitability of the areas where Barasingha can be reintroduced. And now again we have the Barasingha in Satpura Tiger Reserve which are available. This is a similar exercise for giant squirrel was done, where forest department were very keen to know that what are the areas where giant squirrels are present, so that this can also become, apart from tiger, tourists can also see these kind of animals. But they were clueless. They didn't had much sighting apart from one or two. So what we did similar exercise where we took digital elevation model. But interestingly, this particular animal is a arboreal animal. When I say arboreal, means it lives only on the tree, and this needs the particular height of the tree. It can't live on very small height trees. So at least they need 25 meter to 30 meter kind of tree height to make their drays, or you can say drays means unka ghosla. So, and to safeguard themselves from the preying predators, like hawk and eagles, they need to be under the canopy. So their dray has to be hidden. So these kind of requirements were there. So we wanted to understand, and luckily that time from the ISRO glass lidar itself, tree canopy height data was released by NASA, and we utilized that data for making a proper habitat suitability zone. And this kind of map was prepared, and then ultimately we went to the field also for doing the combing operation to understand whether this animal is sighted or not. So with our camera systems and everything, and we could sight many drays. 20 drays were sighted, and then many sighting of the species was also done. And then finally this was also concluded that this kind of niche models can be useful for understanding habitat requirement of the particular species. And this is a requirement of the forest department, and this was a academic exercise we did to understand corridor for the sloth bear in Gujarat and adjoining states, because as you know, the forest areas are now very much fragmented, and there are a lot of events of conflicts between human and animals are also being reported. You can see on the left map where the conflict zones are shown in red color. So there are a lot of killings between sloth bear and humans are happening here in these areas because of the resource overlap. Because people also go in forest area to take out honey or many other things, and then when the paths are crossed, there are events of attacks are happening. So we wanted to understand that whether we can design corridors so that these mobility of these animals are restricted to the forest areas. They don't come out in the open. So for that, there are certain guidelines for habitat and corridor shapes. It should be linear, it should be optimal, it should have, water bodies around them so that they can, not have any problem. And then there are a lot of trees which are having fruit-bearing trees which they like should be available. So with these parameters, we did this modeling, and we have proposed some of the areas which can be grown as a corridor areas. And IUCN is one agency which keeps tab of various animals which are endangered or having certain concern levels. So for them, they keep on modifying their range map. So we help them in modifying this range map as well using environmental data. This is an example of environmental niche of yak. Yak is very sensitive to temperature change, and for them also we did a similar kind of exercise to understand in future what will be the fate of yak in Himalaya, in which areas they can go. Indian gharial are also very sensitive species, and they are declining in numbers because of the habitat loss. So so we also did for some kind of efforts for understanding what are the problems in Son Gharial Sanctuary in Madhya Pradesh. And the major problem was that there was a dam which was built on the upstream, and whenever they used to release the water, it used to wash away the large sand area, where actually the sand are the areas where they give their eggs, and that get washed away. So in a particular breeding season, the entire eggs are lost, so population is going to be hampered. So that was the scenario happening here. So we did try to understand from the hydrological modeling perspective using Mike Shee model that how much water should be safe for release in a particular season for this particular species, and that kind of input were given to them. This is an example from Antarctican South Polar Skua. They are the they fly at a from South Africa region to up to India. They can come, and they mainly live in Antarctica, and they are the top predator. They can kill penguin babies, and they thrive mainly on them, apart from the fishes around. So what we do, we generally tag them. There are some studies done by Wildlife Institute of India. I had a colleague from WII who helped me understand this particular thing. So they used to tag them. You can see the ring in their one of the leg. This is once this squaw is captured, this ring will be retrieved, and there is a consortium in which whosoever capture this animal will upload the data on that particular website. And then the data logger is also there in this ring, and that data logger is a very simple data logger. It is not having any GPS, but it is having solar angle calculator basically. So when it is flying, it is trying to see that what is the angle of the sun, and that sun angle is important to understand which place it was. Okay, because from any place at particular height, what is the sun angle can be computed, and location can be retrieved, but the accuracy will be very coarse. You can say 1 degree kind of accuracy will be there, but it is important for such kind of large area where they move out. So that kind of accuracy can be utilized. And this is one example of how the migratory birds are understood. And this is an example of measuring morphological studies of certain species which are in Antarctica, where recently I went, and then I took some of the digital photographs from the helicopter, and these photographs were later using SFM techniques. We did the photogrammetry of it, and then a precise modeling of you can say seal parameters was done. How it was done, I can just show you. First of all, we did create the planar mosaic of the area, and we tried to measure the length of the seal as well as its girth from it. And why it is important? Because you cannot go on the ground and capture them. It is prohibited. You cannot capture them and then measure them. So this becomes very important if you have drone data or some kind of opportunistic flying that you are having. You can compute these parameters, and you can very well understand what is the male and female ratios, and then juvenile, whether it is there or not. So the health of the entire tribe you can compute. There is the counting of the penguins, which was done using a drone data. We had a penguin island where a lot of penguin colonies were there. So a drone was flown, but counting the number of penguins becomes very problematic if you are going to do it manually. So we try to train a model, artificial intelligence model, where penguin counting could be done. Though the accuracy is not very high, but still it is good enough to have it, because it is very time consuming if you're doing it manually. Though the commission rate was 17%, we found it useful, and we are going to improve this model in future. And when I talk about the forestry in future direction, I feel that 3D forestry is going to be the future, where a lot of LiDAR based information for forest will be generated, whether it is on the ground also. Terrestrial laser scanners are available for various parameter retrieval. So that is going to be our future. Thank you very much. And if any question is there, we can answer.
Thank you, sir. It was a very self-involving presentation. I thoroughly enjoyed. Okay, participants, you have any questions? Sir, I have a question. I wanted to know, like the reintroduction of cheetah in the area of Madhya Pradesh, which is again a habitat which has been shared by tigers. So, is it will it have any effect in the environment and the ecosystem in that region?
Not exactly. They are going to reintroduce a cheetah in India in Kuno National Park.
Yes, sir.
And right now in Kuno National Park, there is no tiger. All right.
Yes.
So it's not a resource habitat, but yes, you're right that from the nearby area in Rajasthan, from there sometimes tigers are reported to come and then go, but it is not primarily a tiger reserve. Kuno is being developed for cheetah specifically. I have recently visited Kuno, and I found that the large area is being converted into savanna kind of thing. So what they are doing is they are cutting the trees and making it a savanna-like system, because cheetah needs a place, open place, grassland to run. Because to catch its prey, it takes off, very top speed of, very high top speed it can go up to. So if it is having a lot of tree species present around, it may not find it very good as a habitat, for preying and hunting. So they are converting the landscape into more cheetah friendly landscape, and initially they are going to have it in the kind of caging system. Where the other species will not be allowed to move into, because cheetah will also be competed with hyena, and there are dog species, the wild, they're known as dhole. Dhole will also compete with cheetah. It has been found that cheetah huntings are snatched by dholes and hyenas kind of animals. So they want to initially, keep them in a kind of area which is separated from that. So it is not going to be a conflict of interest between tiger and cheetah, but definitely it will be interesting to see how the reintroduction program goes on. Thank you.
Thank you, sir.
So there is another question coming up with the students. They want to know how hyperspectral data will be used for wildlife and forest fire management, corridor mapping.
Oh yeah. Hyperspectral data is really useful for many things, but definitely so far we have not used it for forest fire, because the examples that I have given you is for active forest fire detection. And you may have seen that generally hyperspectral sensors are not designed in the thermal domain. Okay, they are mostly in the optical domain. So active forest fire part can be omitted, but yes, definitely if you want to understand the burnt scar, how much area is converted into charcoal, how much area is completely ash, those kind of things can be derived using hyperspectral data. For the corridor mapping, hyperspectral data is useful in a sense like you can compute health of the forest. You can compute the various other parameters like, but it will depend on which species you are talking about. Whether it is a species which is mostly concentrated on a particular fruit tree species or not. So the fruit tree mapping will become very important for that particular species. Because recently, like I'm not showing you example, which there are certain work which we are undergoing, that like flying squirrel. Flying squirrel is a very specific species which comes down from the tree only when it requires water to drink, So you need to understand that what kind of water channels are available, the third channel, very high level of hydrological or DM kind of information will also be required apart from fruit tree species availability. So I don't see that even hyperspectral will be required for some of the species, but hyperspectral is very much required for species level mapping, and which can also help you in corridor kind of mapping to be done.
Sir, how can we prepare forest type and density map using satellite remote sensing, and which data is more accurate?
Yeah, for forest type and density. For density, you can utilize any high resolution data, which is having specific bands like NIR and RED, and NDVI can be computed, and NDVI is directly going to give you indirect estimation of leaf area index and the density. So far, people do through it only, but we know that this is not a direct evidence of density, because sometimes you get to see grasses beneath the tree which are not very dense, and that can hamper your estimation. But with all these limitations, this is the best technique which is available for density estimation. Apart from until unless you are having a LiDAR kind of sensor, LiDAR is going to give you the perfect estimation of the density, where every stand and canopy fuse canopy will come out very nicely. Okay, so LiDAR, I would say as a technique, LiDAR will be the best technique for density estimation. In absence of it, any optical data, high resolution optical data can also help you.
Sir, somebody is asking you, what are the reasons of human and animal conflict mapping nowadays?
What is the reason? Reason is mainly resource overlap. When you share the territory, there will be human-animal conflict, because I talked about the sloth bear. Sloth bear mainly the time when it matches. Generally they early morning or late in the evening, sloth bear will come out from its den. And if villagers are moving during that time period, whether they are coming out after working in the agriculture field or early, going to the agriculture field, and if they are crossing the same path that time, and if it is carrying a baby, that time it will be very ferocious and it will attack. So people need to understand their behavior, and they should know their timeline when they move out, and at what time they are more prone to attack and kind of stuff. So that can avoid such scenarios. Otherwise, the main reason is resource overlap. We have encroached into forest. We have gone deep into the forest for doing agriculture, where these animals are supposed to live. So that's the main reason.
So there are a lot number of questions, but last two I'll be taking up. First question is, which data is best suited for Himalayan studies, especially in upper reaches?
In terms of remote sensing data, I would say hyperspectral data is the best data which we can use. But problem with the hyperspectral data is right now from spaceborne platform, it is not available. Last hyperspectral spaceborne sensor was Hyperion, which is not available nowadays. And I don't see in near future anybody's planning in near future any launch is there. So, but in absence of it, I say in today's scenario, Sentinel is the best option. And for mountain region, you are aware that when we use microwave data, there are a lot of layover and foreshortening effect which comes out. So optical becomes very good for those reasons. Thank you.
And last question, sir. Which data will be helpful for desert-based forest mapping?
Can you repeat?
For desert-based forest types like bubbles and all, which data will be more suited?
Okay, yeah. Prosopis juliflora mapping you are referring to. Recently, we did for that also. Invasive species, basically, it is. And you must be aware that this is a evergreen tree. And luckily, it is more prevalent in the desert area, as he is mentioning. So from separating from other species, native species to babul, you can do very simple analysis. That is based on the phenology, you can segregate them. Since babul will be throughout green and other species will shed their leaves during winter time, you can very well separate these two species when you are classifying. So you can use Sentinel, Landsat, any data, and you can classify Prosopis juliflora very easily.
And last, sir, last question is how which data will be more suited for a flood forecasting modeling?
Flood forecasting. This is a question, I don't think it is related to my talk today, but flood forecasting is something which can be done using meteorological data. So if you can forecast, first of all, rainfall, and then you have DM data available. So given a particular inch of rainfall, you can compute that how much flooding will be there. Okay, so as a DEM can be utilized, very high resolution DEM can help you in understanding that how much water logging is going to be there in which area and how much time it will take to recede. So it will require a lot of modeling effort using hydrological models, which are also nowadays available in GIS platform. Otherwise, there are very specialized softwares are also available like MikeSheet. So you can do hydrological modeling and flood forecasting using those data sets and those kind of models.
Thank you, sir. I've taken all the question. Still, if any question is left, you can ask to sir directly.
Yeah, sure. You can even email me.
Hopefully, I have covered all the questions. Priyanka, please continue further.
Yes, sir. Yes, we have come to an almost the end of the first half of the session today. Thank you, sir. It was a very, very interactive and interesting presentation from your end. And with this, I also require all the students to again be present for the second half of the
At 2:55.
session.
2:55.
2:55 we'll meet again so that we can start with the next speaker of the day.
Thank you, sir. Thank you, sir, for
Thank
giving
you.
your valuable insights about applications of remote sensing data either in forest fire, phenology, wildlife. It was an extraordinary session, sir. Thanks a lot, sir, and keep blessings us.
Thank you, Suraj. Thank you very much for inviting me.
Thank you, sir. Thank you very much
Thank you, Shruti.
for
It was
giving
pleasure.
really very interesting, because I also work on forest fires, so, sir. So even the untouched part of my work, for which I got some ideas now to pursue with your insightful guidelines. So we will be surely asking you or disturbing you for further guidelines in the same research to carry on in future. Thank you
Yeah,
so much.
yeah, sure. We can work together. No issue. Thank
Yes,
you.
sir. Thank you.
Thank you, sir. It is a wonderful presentation. Thank you so much.
Yeah. Again, we'll meet at 2:55 p.m. for our last lecture today. So we have got another invited speaker. She'll be joining at 3 o'clock. So because we have got an extended session, so at least we need 1 hour break. So we'll start up with 3 to 4. That is the last session for today. So better you join by 2:55.
Okay, sir. Okay, thank you.